Well, good morning, everyone, and welcome to today's webinar. My name is Sudeep Kumar Das from KTech Center of Excellence for Data Science and AI. Today's AI Pathshala is a series of, today's AI Pathshala is going to focus on demand forecasting using deep learning. And as you know, the AI Pathshala series is basically focused towards technology workshop that facilitates peer-to-peer interactions led by technology experts like Professor Chandrasekhar in data science, in AI, and areas like NLP, computer vision, high performance computing, product development, etc. So today's AI Pathshala will also be a fully hands-on with real life data. Minimum theoretical concepts will be covered as and when required along with the hands-on session. And Professor Chandrasekhar is going to use open source GUI based software, KNIME, and which is a very powerful for text and image processing. By the way, just for your information, KNIME has been placed as a leader for data science and machine learning platforms in Gartner's Magic Quadrant in 2021. With that, it is my great honor and pleasure to introduce our speaker of the day, Professor Chandrasekhar. Professor Chandrasekhar Subramaniam is regarded as one of the top analytics professor in the country today, and he was the chair professor and officiating director at the Ford School of Management, New Delhi. He holds a PhD from University of Georgia and master's from IIT Kanpur, with a vast experience spreading over 34 years in R&D, academia, industry in the area of quantitative techniques and IP. And Professor Chandrasekhar has published in several international and national journals and presented papers and chaired sessions at national and international forums. He has patents to his credit, having filed a patent jointly with IFIM, and he's working on his next patent in the area of text mining and financial analytics. So before I hand it over to the professor, I would request that, if you have any questions which is directly related to the topic, please queue in the questions in the Q&A panel. Today, I'm also joined by my colleague Supriya, who would, present the questions to the professor and manage the break as well. And as you're aware, we take breaks at regular intervals. So as we are starting at around 10, and the break comes up at around 10:50 to 11, and the next one would be 11:50 to 12, and the next one would be 12:50 to 1. All right. And for anything related to the platform, or you're unable to hear, etc., you can use the chat window. Let me repeat once again, for any questions related to the session, related to the topic, please queue in the questions in the Q&A panel only. And your good mornings, good evenings, etc., please keep it for the chat window. Apart from that, my colleague Supriya would also share a link to the survey. Please fill in the link or survey at the end of the session. And again, we are looking forward to a cracking session today by Professor Chandrasekhar. Sir, over to you. We have close to 100 plus attendees already. And if you can start sharing a screen, sir.
Sure.
I can see your screen. Sir, you can use Control L for a full view, full screen. And escape to come out of it.
Okay.
Perfect, sir. I can see your
screen. OS. Thank you, Sudeep, for the very kind words you have spoken about me. I think all the participants' expectations must have gone up very high with this introduction. Let me try my best to keep up to that level. So this demand forecasting is a very dear subject to me. In fact, about 25 years back, almost 25 years back, I taught this course both within the country and at Manchester Business School also. It is almost a 1 semester course. The maximum we can compress is for 2 months. Now, you know that 2 months I am somehow trying to push it in 2.5 hours or 3 hours. It is very difficult to do justice for this. The whole objective is it will give you somewhat overall idea of what can be done and how to go about it. Otherwise, you can see the vast range. And that too with this, what we call so-called new data sources, like images and voice coming into picture. Images, voice, text, they come into picture nowadays. These are called the alternate data sources, or what we call the unstructured type of data sources. To get a better accuracy, what has to be done is what I teach today. That should be combined with other unstructured data analysis like text mining, image analytics, or voice to text conversion. They will give some additional information. Those additional information has to be combined with this. Then only you will get accuracy, because what is happening is apart from our what we call the usual data like quantity sold, price, promotion, etc., a huge type of demand gets accumulated by the word of mouth, by the reviews you write it on the platform. Then our social media sources like your Facebook, Instagram, LinkedIn, etc. Now those type of information also play a major role, because when these classical forecasting models were used, those alternate data sources were not there. So somehow we were not capturing that data into these models. But as and when these new data sources have come, that also has to be captured. And there is a lot of research work going on. How do we convert those type of unstructured data into some type of a structure, and then incorporate it along with the models which I teach today? That is what has to be done in the future. Covering both of them in a single session is difficult. That is why last session I covered the text analytics and all. How do we derive sentiment from the news, from alternate data sources? You get that number. That number has to be combined with whatever I am teaching today. And if there are emotions or other things, they are images. They come in the form of an images. By analyzing those images, I can somehow quantize that emotion, those type of things which we can derive from the picture. That becomes additional variable. So if you put those things, then your demand planning or forecasting, whatever it is, will become accurate. If you simply use only structured data, where these models were developed almost 15 years back or 16 years back, you will get a forecasting error of sometimes 30%, 25%, 20%, etc. I think within current day is an unacceptable number. They almost want 95, 96, 97. This will not yield. We have to merge those alternate data sources with this. So that we will hold a separate session. Part of it I have already taught on the 20th masterclass which I taught. One more we will teach on the computer vision. So what all you have to do is you will have to integrate all these things: structured data, unstructured in the form of a text, again unstructured in the form of an image. Somehow we will extract all these information, because computer can understand only numbers. Somehow they have to be converted to a number eventually. You can't put a picture along with this sales data and then say analyze. No. Somehow either a count has to be put, or frequency has to be put. Something has to be put there. That we derive from the data, from these images. And that is what should go into the model which I teach today. So what is start is 70% or 80%. And that has to be integrated with this. That's what it is. These PPTs and all I will share. I am not going to teach too much of PPTs now, except for your 1 or 2, 3, 4 PPTs is what all I am going to teach today. Then we will use that open source tool KNIME, which I think Sudeep briefly mentioned. KNIME stands for Constant Intelligent Miner Engine, that started from Germany, from a research institute, and eventually it became a product. The headquarters is in Zurich. It is in Switzerland. KNIME have about 70,000 user community. There is a KNIME India group also, about some 700 or 1000 members are there. There are other competing products with KNIME. One is the Rapid Miner, the other one is Head2O.ai, the third one is, what is that? There is some big data, ML or something is there. But the advantage of KNIME is all those your other competing products, only 50-60% are open source. When you come to developer app, explainable, shift this model to production. No, they are not free. You will have to pay the money. Whereas KNIME is completely open source. No record restrictions. You can analyze millions of record. In fact, the Walmart forecasting itself is done using KNIME now. You can see the volume. I think virtually they have analyzed 20 million or 40 million records using KNIME. So it has worked. You can see it in the KNIME side. That is, I think, one of the largest demand forecasts that has been done with the volume. Almost 30 million records analyzing is not a joke. It is terribly tough to do it. And you can take the model from your lab to the production. KNIME has all the modules for that. There is something called an explainable AI. What happens is, when we use this deep learning type of models, it becomes very difficult for a person to explain how did it took the decision. Okay, you see some forecast numbers. If you ask it, how did you get these numbers? What did you do? No, there is no way. You can do in our normal method. That is what is called the explainable AI. We will do it at some other time. It tells you what are the variable, which variable is important. If you change it by 10%, what will happen to your market share? If you reduce the price of the product by 10%, what will happen? This is what we call the sensitivity analysis. That can be done using that XAI. It is called explainable AI. There are something called Shapley values and all that will allow you to do this. So that part we will not cover today. And there is one more part, which if some time permits, I will cover. These are called forecasting the short life cycle product. Whatever I showed today, you need some amount of data, some at least some 300 data point, 200 data points. The short life cycle, like fashions, mobile phones, cosmetics, they have a very short cycle. In 6 months, 7 months, that fashion will vanish from the market. So they are called diffusion innovation type of model. That is what we call a differential type of models. If some time permits, I will show it today. Otherwise, we will definitely hold one session. That is for the short life cycle. If you do not have data at all, this is the last point. If you do not have data at all about this, that is, if you don't have either sales data for the last 1 year, 2 years, if you are doing a weekly forecast, at least you should have daily data if you are doing for the next 45 days or 60 days. You don't have anything. So somehow you are starting with a new product. At least some test marketing data will be there. That will be very much minimum. What normally we do in real life is we don't do an all India launch at first time. We do some test marketing, some basic data we will collect. Some 30, 40, 100 data points like that. Using that, if you want to do a prediction, these are what are called the simulation type of models. That I will not be covering today. Then this will take one full day to cover. To do some minimum justice. So short life cycle, if some time permits, I will show. Then you are what we call without data at all. Some short test marketing we have done, some 200 or 100 from different parts of the country only we have collected. North, south, east, west, etc. That we will do simulation. That is called what is called the simulation. That we will not cover today. We take some distribution, do some random samples, and then finally come out with the sales distribution. That is what it is. That is what we call the new products. So new products simulation. If you have short type of data, for example, these fashion, cosmetics, etc., mobile phones, most of the phones will vanish from the market. Hardly 3 months, 4 months, it goes off. For these type of products, we have something called the short life cycle forecast. What we call the BOSS model. BOSS model has improved over a period of time. I will tell if some lot of research students are there, what can be improved over the BOSS model, because when BOSS developed the model, there was no unstructured data and all. So that model doesn't take unstructured data. You put unstructured into that, becomes another 10 to 20 PhDs can come out of this. So much work is there. That part, I think some of you should do that one. So time series, I will give the definition of time series. There is some basic confusion. So what happens in time series? The time interval between two observations remains the same. What we mean is, if you have daily data, it should be daily throughout, whatever data you have collected. You can't have some 10 daily data, again bring one weekly summary, then again continue with the daily data, then somewhere push monthly sales and all. No. That violates the definition of time series. So the definition of time series is between two successive data points, that interval should remain the same. It may be weekly, it may be monthly, it may be quarterly, half yearly or annually. That is not the matter. What matters is the time interval should be the same. That's what it is. What it means is, you cannot have 1 week data, then suddenly bring 15 days, then after some gap you start again bringing 1 week data. No, these models will not work. They will fail, because that violates the basic assumption of time series. The second one is, normally time series should not have a missing information in between. So what they recommend is, if you have a missing information, you should fill that before using the time series model. Otherwise, what happens when I take the moving average and all, let us say 1 day or 2 day misses, then the whole sequence is getting affected. When I take a moving average of last 3 days, assume that today we are in Wednesday, assume that there is a stock market data, we want to take the last 3 days moving average. So the average will be for Tuesday, Monday, and then last Friday. Then next time when I come in, the next time, if that Wednesday, if the Tuesday data is missing, what this will do, it will take the previous data, that is Monday it will go, then 2 days previous it will go. It will do Monday, Friday and Thursday, which is totally incorrect. That is why we insist that you should not have some missing observation in the time series. So if you want to use time series model, what happens is, you will have to fill it. Now the next question that comes is, sir, I do not have, there are a lot of missing information, we are not able to fill too much missing information, what do we do? Then what you do is, there are other models like regression, and we have something called a decision tree that you use, because they will not insist the missing data. It clubs them as a separate class. So that way you are saved. But forecast may not be that much accurate, because you have a lot of missing information. But in worst case, at least you get some rule of thumb. So if there are no missing data, if the time sequence or the time interval between the two successive observations is the same, you can use all these time series model, which I will cover. So if there are a lot of missing observation, and if there are some infrequent thing, it violates the assumption, then what you have to do is, you will have to use the decision tree. We have something called a computer analysis of regression trees, what we call the CART. You use a CART model first, build a basic decision tree, see the accuracy. If your accuracy is insufficient, we have other ways of handling. We have something called the ensemble building. Instead of building 1 tree, we build 10 trees. Take the average of those predictions. That is the forecast. That works. But the only penalty you pay is, your accuracy will not be equal to accuracy of time series, because you have some missing observation, and in between, instead of week, you start giving some 1 or 2 places monthly data and all. That is what happens. So we have to be careful at that. Whatever I spoke, this course material is there. We will circulate all of them. I will circulate all of them. So 1 or 2 I will just show. It is used in almost in econometrics. It is used in financial markets. It is used in marketing. I think even in HR, there are ways to predict when the employee is likely to leave or how long he will stick. They are the things. So whether I think any domain, we should be able to use this, as long as you have time series data without missing observation. If there is a missing observation, you fill it and use the time series model, because your accuracy is more. And most of these time series model, they use what is called a linear model. There is a linear relation between the price and the sales, or something like that. So if price increases by 10%, Sales will increase by 10%. These are called linear models. Most of the time, this will not happen. If you reduce the price by 10%, sales may increase by 25%. These are called non-linear models. So the good old days back, we had good amount of these simple time series model like exponential smoothing, moving averages, then what is called the auto-regressive integrated moving average, what we call famous ARIMA. These are called linear models, but they will not capture this non-linearity because there is a high non-linearity. I reduced the price by 10%. So share did not go up by 10, it became 25. I increased the price by 5%. And market share will not reduce by 5. It may reduce by 10 or 25. So these are called nonlinear models. For nonlinear models, we use deep learning. That is what I am going to show. So there will be some 3 to 4 demos. One using good old time series, where we identify the seasonality trend and the random component. We try to do this. Then second one I will show using the deep learning, where the complexity is quite high. It will be able to be a better method. And there is another common mistake normally is done, because I have analyzed the time series for a large number of companies start the course. What is happening? The tendency is we try to build a single model for the entire data. It never works. See, this data consists of what we call the numeric variables and the non-numeric. Let us take that retail sales data. You have sales. Then we have promotion also. Some point in time, you would have put a promotion. Then there is a brand. There is a category. There is a region in which the store is located. The store itself. Now, except sales and that promotion, all others are non-numeric variables. Like the pin code, like a location, north, south, east, west. Within north, you have district. Some 5 districts of the north. Within that 5 districts, we have the store location. Do you see the problem? They are all non-numeric. Brand, non-numeric. Stock keeping unit is non-numeric. What I am left with is only the sales and some maybe the price or a promotion, or 2 numeric columns and some 7 to 8 non-numeric column. No forecasting will work like this. The tendency is we try to build a single model. For all this, no, don't do it. Then what you have to do, it becomes a 2-step forecast. So we use a decision tree first to cluster these locations. So which brand, which store, which zone has large sales. So you use a decision tree. What you do, you take that sales as a dependent variable, and all the non-numeric variables you take as independents. If time is there, I will show it. Unfortunately, if time is not there, I am not able to show it. The decision tree will give you the clusters. So maybe I may end up with 10 clusters or 15 clusters. Then instead of building one single model for the entire country, we will build 15 models. That works. If your data is large, then if you have a large number of what we call non-numeric variables, store location, brand, SKU, then the state, district, etc., then profession, who are buying, if you have captured that, occupation, whatever it is. So profession and all are non-numeric. So don't try to build a single model. It never works. Your forecasting accuracy will be 60 or 75. Then you don't know what to do. So what the recommended method is, it is a hybrid type of forecasting. You use the decision tree to get the clusters first. Let the decision tree not predict, because the prediction, it will be very poor. So you simply use it to get the clusters, which approximately gives you in what part of the country, which store, which brand, which SKU has the highest sales. So you separate that first. Then build a separate model for that. Like that, normally you end up with 10 or 15 clusters, depending on volume of the data. For each of these 15 clusters, again, no single model works. You see the complexity. At least you will have to build 5-6 models. So you will have 15 into 6 is 90. 90 to 100 is the common number of models we build if you want to do any forecasting in real life. For our R&D, we have only 1 Excel sheet, 2 Excel sheet. No, that's all you will forecast. No, not in real life. Normally what happens is you will build some 70, 80 models. Each store, each location, each district, each zone, like that. Then one model you select the best, that goes to production. Now, as and when new data comes, the variability in the data also changes. Now, I will have to retire this old model and push the new model to the production. So production people will not take the new model immediately. If you say, no, we say you prove it. So now what happens? This new model will be put on hold. So we build the new model. Maybe the accuracy would have reduced. Your old model was giving 85% forecasting accuracy. Suddenly data has changed. Some competitor has come. He would have reduced the price, etc., etc. Your data suddenly changed. Now the model accuracy has come down to 75. Now there is a trigger there. Now that what we call the deployed MA, it triggers. And you get a message. You means the developer or whoever did the model, you get a message telling that the forecasting accuracy all these days was 85. Suddenly, from yesterday, it has reduced to 75. Now you have to start building the new model. The whole process gets repeated now. It may give you which location, which store, etc. You don't have to build all. And that model, you will have to prove it for 1 month or 2 months. Because suddenly if you put it, if it is a one-time type of volatility that has changed, then again your old model works better and this new fails next week. They cannot take the risk. So this new model will be put under probation. And after some time, that old model start degrading. From 75, it becomes 72, they will cry. The salesman will arrive, what is happening, my dear boss? How can I use this forecast? Then in the parallelly, you build this new model, push this model to production. This is how the operational part of planning takes place. If any questions are there, I will answer till we wait till the end. Let me clear it.
Sure, sir. I'll read it out for you.
Please read it.
Yeah. So first question in the beginning was demand prediction versus demand forecasting. We have this question from Krishna.
No, most of the time these words are used interchangeably. There is not much difference between them. Yeah, in US and western part of the country, they call prediction. Some other countries will call demand forecast.
Yeah, so it's one and same.
You read all that US books, he call prediction. You take my Indian author, you will see the other word.
Got it, sir. Got it, sir. So the next question is from Narayanan. He's asking, if we do not have the secondary sales data from dealers for FMCG products with only primary sales data, how to predict the demand?
No, then what you do, for which data is there, you will have to predict. Then what happens for each store, you have to do the breakup from that point. See, what I am doing is, if I take that Himalaya, I think you take one thing, like detergents, or you take one of the detergent. Now, what is happening? You have primary data at some level, maybe electronic city, your HSR layout, and then PTM layout, etc., etc. Combined, you have one forecast. Now, as a salesperson, approximately you know that secondary data, what percentage is going to store number one, that you will have to do manually. That is how in general it is done. What we do, forecasting model is not normally done at that level. Normally it is done at the brand level or the warehouse level, or at the next level, maybe your major distributor level. Up to that we do the forecast. Otherwise it becomes too erratic. Data will become too noisy. We get lost. So what happens is, okay, there is some distributor who covers these 4-5 levels. You give it to the distributor that forecast. Now what he will do, he has some knowledge. Okay, that BDM layout, normally it is 30% of this demand, 40%. That he will do it normally. That is how it is done.
Sure, sir. So another question is from Naveen Pari. So he has two questions. The first question he says is, I assume region 1, 2, 3 come under cluster 1.
Correct.
How do we distribute the sales demand within the cluster?
No. Now what happens? You know that cluster 1, 2, 3. Within the cluster 1, 2, 3, you have daily sales or weekly sales or whatever it is. That will have about some 200 points or 120 points. If it is a weekly data for 2 years or 1.5 years, you will have about 70, 80 points. You will have to build a model for those 70, 80.
Okay, sir. So, sir, another question is from Deba Smith Mohanty, and he's asking, can we use variables like variability in time and variability in demand to cluster SKUs?
Definitely. Variability, yes, it can be used because it is a second order variation. So variability can be used. So how do we compute variability? There are some simple methods. The other method is normally what we do is we do that exponential smoothing at first level and get the variability, and that goes as a forecast. And if it is a financial data, yes, we have very good models like ArchGarch, what stands for what is called that auto-regressive conditional heteroscedasticity. They build the variability. So what you do, it is like this. Your forecast, all these forecasting models, they will give you that single point forecast. The variability, there are two methods. You can predict the variability separately as a time series. Then around that point forecast, you say, if I take that plus minus 2 times that variability, the lower bound for the forecast is that, and the upper bound for the forecast is that. That is one method of using that variability. Don't mix it. So variability is again a time series. So let us forecast the variability for the next 1 week or something. Now you have a point forecast by using the time or price or whatever it is. Now what you do, take 1.5 times that variability, that whatever is the forecasted demand plus 1.5 is the upper demand, and that forecast minus 1.5 times the variability becomes the lower demand. Then you get a bound for the forecast.
Sure. Sir, Sabri Kumar has a question. Is clustering a part of unsupervised learning?
Correct. But what happens, since in this case, since you have some sales or some dependent variable already measured, instead of simply using a cluster, we use a decision tree which gives better clusters, because decision tree is a supervised type of classifier. So any day supervised classifier is definitely better than an unsupervised one. So since I have sales, which is a dependent variable, I will show that, then it becomes more clear to him. I am going to exactly do the same thing now. What he is asking, I will show it. We have some supermarket sales data or something that will help him to understand it. I will virtually use that KNIME and then show it.
Sure, sir. Sure. Then another question is from Jasmine. How do we handle high cardinality data such as PIN code, etc.? This can lead to a very high number of models. Example, 100 PIN codes, gender to give 200 models. So this can become very large since all variables are being multiplied.
No, madam, what is happening is, that's what I said, we don't do the forecast to that PIN code level. See, what is happening in the PIN code also, there are some locations where when you take southern part of Bangalore, what happens is southern part of Bangalore may be covered by 30 PIN codes or 40. I am not going to do that at PIN code level. What I do, the forecast is that level. Then what happens, some distributor, somebody will be there to physically take it to those locations. They will have some idea. Out of these X number, okay, 17,500 is the forecast for some shampoo or something for the southern part of Bangalore. Now the South Bangalore, when you overlay a geographic map on this, I know how many stores get covered in that region. Now there is a salesperson or somebody going to those locations, he will have an idea. He will come and tell you, this much I will take it to that level, that much I will take it to northern part of Bangalore, this much I will take it to eastern part. That is how it is done. What she says is correct. Then we will become mad. You will end up with lakhs of models. Oh, PIN code for Bangalore, you take my entire country, then where are we now? No. Production people will not do. Production people, what they do, they aggregate your demand and then do your production. He is not worried about specific store. That is the level. What all we do is at best, at worst case, we will do it at some region level or brand level like that. We are not going to do it at stores level. You will become mad. You will end up with 1 lakh models.
Yeah, true, sir. Okay. So another question is from Sarma. Are there any approaches to minimize the number of modules on a real-time scenario?
Minimize, what I said is during our study time, we build 5-6 models. And in that 5, 6, one of them happens to be the least criteria. The normal criteria with the industry uses is what is called the mean absolute percentage error. So if your MAPE is up to 10%, it is a good forecast. 15 to 10, sometimes we will accept in the absence of anything. Less than 15%, that model is not suitable at all for deployment. What it says is either some new data has to be put into this, or you will have to wait some more time. The data points are insufficient, so the model could not deliver the expected accuracy. That is what it is. Up to 10% mean absolute percentage. There is something called RMS error, absolute error. We don't normally go because it becomes difficult to interpret. MAPE, every fellow will understand mean absolute percentage error. That means I will make only 10% error between my forecast and the actual. 15 to 10 also, sometimes they accept. What happens is 15 to 10%, for large volume items, it becomes very large. If it is a Maggie or ketchup and all at that level, no, they will sell in lakhs. So even 15% will become large. Whereas if you take at Nestle level and a brand, that's all right. So what normally happens is up to 10%, it is a good forecast. 15 to 10, depending on the environment, we will accept. Less than 15%, we do not use that model at all. Something more we have to do for that.
Okay, sir. So, sir, there are now 3 questions I see on the screen. Would you like to take them now or later?
No, we will answer it.
Okay,
why should they wait that long?
Sure, sir. So, Narayanan is asking, collaborating demand planning with dealers, distributors in the absence of daily sales at point of sale, how it is done through a software?
No. See, what we do, normally we do the forecast at a weekly level. No, that has to be, no. I think we don't have any model to do what he is asking.
Okay, yes.
What worst case that happen is there may be a similar zone similar to that. If the data is missing, we will have to replace it with that adjacent pin code or something.
Sure. Next one is from Abhishek. If we not have enough data points in time series, can we use clustering to increase data points?
No, there is an issue here. What happens? Clustering can be used to increase the data point, provided there are some numerics. What we do is we fit a distribution. There is something called synthetic minority oversampling, that is called SMOT. Now that with that fictitiously I can increase, but for the non-numeric data, I don't know how you increase. Oh, there is an issue here. See, numeric data, we have some ways. What we do is we fit a distribution and then increase it. For this, there are some ways like that K-mean clustering and all, which identifies somewhat similar records within the data set. It's not going to grow the data set. See, you will get, okay, if there are 50 records, you take record number 7, it says 13, 14, 12 and 11 are similar. Now, in worst case, what you have to do is you have to take the mode of these non-numeric variables, and then for the numeric variables, you fit a distribution and do that Monte Carlo simulation. Then you will have to merge with this. That is a complex process, and we don't know in real life whether this really works. I think nowadays, no, data is not an issue. We have all these point of sale devices, mobile devices coming into picture. Data is captured, I think, at more frequency compared to what it was 5 years back. What we are worried is how do we aggregate the data? That is the issue now. If it is a new product, that may happen. What he is telling may happen. That I said we will not cover today. We will have to do some simulation and wait for data to come. Till such time, we can use some aggregated forecast, somehow manage the show. Errors may be high. That's how the salesperson also learns and eventually gives you how do I distribute an aggregate forecast to his level.
Sure, sir. So last question on the screen is from Deepak, and he's asking, do we need to take care of the time frame of data for training? Like should prefer last 3 months data rather than 6 months or 1 year, or we should go for whatever timeline that data is available for?
No, roughly the breakup is 20-80. Whatever that X data points he has, 80%, 75 to 80 is what we used to build the model. 25 to 30 the validation set. So if he has some 2 years of weekly data, 52 plus 52. So roughly it will be about 110 points or 120. In this 120, take roughly 80%, that is 96 or 95. So 95 points, we will use it to build the model, whether it is your normal or deep learning. Deep learning, we have to be a little bit careful. It requires more points. At least your other models, you can use it using that 95 or 94. Then validate it on the next 25%. That gives you a confidence, how confident we are on an unseen data, because fictitiously we are assuming it is unseen, but it is actually seen. So we compute the mean absolute percentage error for this 25% which is unseen, then deploy the model. That's what the error I gave you, that 10%, 15% and all, this is not on the training set. So training set, you will get wonderful accuracy because the model has already seen. So you should never use this training set accuracy. No. What all you have to do is you will have to use that balance which the model has not unseen. That balance 25% or 20. For that MAP is what I am talking, not on the MAP which used to build the model. That will be almost 92, 93, 90. Don't go by that. That will always be higher. You see the value for the validation set, or what we call the test set. Now the test set is roughly between 25 to 10 to 20 to 25. And that validation and the training set, what we call, is from 75 to 80. This is the normal breakup on the data, independent of how much he collected.
Sure, sir. So with that, we have covered all the questions on the Q&A. But again, I see another 3 questions which have...
One I will answer then.
Okay,
then
okay,
otherwise, for the demo, they may be left with less time.
Sir. And we have just 5 minutes left for the first break.
So I will answer 1 or 2. Then I will start directly with the demo. This course material I will send you. There is a book also which is used to teach the course, because I myself have taught this course for almost in some 7-8 places. So that can be supplied. I will directly show you the KNIME, how pre-processing is done, how we build a workflow. That I will show.
Sure. So, sir, quickly a question from Bhaskar. What are the essential points to keep in mind before subjecting any data to the tool other than quality of data?
There are something called outliers, correct? So what happens, few isolated data points, they will terribly upset your model. That is, your accuracy drastically comes down. So there are 2 methods of identifying the outliers. If it is a numeric data, we are talking for numeric data. For numeric data, what you do is you take the mean value and add plus minus 2 standard deviation. Plus 2 standard deviation is the upper bound for the usual, what we call isolated data point. And then minus 2 is on the other side. So what we do, all these data points which are beyond that average plus 2 sigma, there are many methods of doing it. So what you do, I will tell you 2-3 methods, or I will tell it afterwards. So they are what are called the outliers. Now, this outlier means it will happen only once in a way because of some policy change or some drastic environment change would have happened. So you replace them. One simple way of replacing is with the mean itself. You simply replace them with the mean. No, then you are pulling the value too much. So what you do, all those data points which are above mu plus 2 sigma, replace them with mu plus 2 sigma. That is the closest point, which is not an isolated point. Then you have mu minus 2 sigma. So all the points below mu minus 2 sigma, you replace them by mu minus 2 sigma. If you take an example, let us say the mean is 150. Let us take sigma is 20. So mu plus 2 sigma becomes 150 plus 40, it is 190. Somewhere you will have a data point like 250, 270, 200, etc., etc. Now all those 250, 270, 240, whatever it is, replace it by 190. Do not replace with the mean, because mean becomes 100. So you will pull them very much. That should not happen. And mu minus 2 sigma, that means 100 minus 80, which is 20. Now, if you see some points like 7, 4, 1, etc., replace all those 7, 4, 1, 2 by 20. Don't put again this mean. Then you will be uplifting them by too much. Then your model accuracy goes for a toss.
Sure, sir. So, sir, we have the first break at 10:50 for 10 minutes. So, shall we go for the break and come back at 11 o'clock?
Let them come at 11 and I will show you the KNIME. We will have some real life data. I think probably they will be able to understand. Half of their questions will get solved also by looking at the demo. They will actually see how it is done like that.
Sure, sure. So participants will take a very quick break,
sure,
and I request you all to come back by 11.
Sure.
Thank you, sir.
Sure. Shall we start?
Yes, sir. We can. We can.
So this is how the KNIME menu comes. The site is www.knime.com. You go to that site, download KNIME. So basic KNIME you download. What happens is, if you want to use the deep learning part of KNIME, the model which I am going to show, it requires minimum of 8 GB RAM, because you will have to load Keras, you will have to load TensorFlow, all that. The backend is the Keras. That is your Google AI library it uses. Only thing is you have a GUI, so that you don't have to go edit those files and then compile the code and all. That part is saved. If you want to do some basic statistics, that minimum, what we call the basic modules of KNIME gets loaded. That runs in 4 GB RAM. And if you want to do that image analytics, text mining, etc., along with deep learning, they recommend 16 GB, but it runs in 8 GB. Because earlier my own machine was 8 GB, it was running. But only thing is, for doing text analytics and all, you can't put some 1 lakh news and then 2 lakh news to analyze. Somewhere around 40, 50, 60,000, that level it works. KNIME is from one end to another, starting from that basic line graph, bar graph, ANOVA, GANOVA, regression. It will go up to image analytics, including text analytics, including the deployment part, what we call the explainable AI developer app. How do we move it into production? How the triggers can be written so it can be deployed to production. And this open source can be deployed in production. For commercial purposes also, you can use KNIME. I have got it clarified from the CEO of KNIME. Maybe we will circulate that mail also to you. The only open source which allows you to deploy for production. Other two open source like H2O.A, Rapid Miner, there are 1 or 2 more. Abacus, all these are there. No. For deployment, it is not free. You will have to take a license. That is the difference between this and that. So this is, I will open one. This is where all your workflow. See, this is a workflow. So these are called the nodes. Each node will do a specific work. These are called the nodes in KNIME. The total nodes in KNIME may be around 2,500 or 3,000, combining from your basic line graph, P graph, bar graph, and ANOVA, MANOVA, all that regression, all that most of you are familiar, including image classification, etc., all that. It goes up to 2,500. That is the total number of nodes in KNIME. And it supports also, this is where your workflow is saved. I will open this file. If you want to import a workflow, suppose I will send you the workflows, you use this import command. I will show you later on how to import a workflow, because I will be sending the workflow, you will have to import it. We use import. If you want to mail the workflow to your group and other people in the organization, you can use this export workflow. There is something called install KNIME extensions. So for your deep learning, text analytics and all, you will have to install these extensions. To install an extension, you click this install KNIME extensions. some menu will come, he will scan what are all the extensions that are already installed. These I have not installed. For example, this big data extension, of course, KNIME can read something like 50 to 60 different type of files, including your CSV, Excel, then your Access, then your SPSS, SAS, some ERP files, then image files, audio file, text file, I don't know, and all your PDF files. In fact, it can extract a text from the PDF file, which hardly it is a very tough part to extract text from a PDF document, because you will have picture, you will have table, all that. KNIME is able to do that. So all that Spark, Hadoop, all that connectors are there in picture. So some bioinformatics and all I have not loaded. So if you see what is already installed, you just click this. These are all the extensions I have installed. See, all these image processing, text mining, deep learning, all these are, and your H2O connector also. If part of the module is developed in H2O, you can integrate with KNIME. That is their competing product. All these image processing is here. Machine learning interpretability. This is what I was telling. This is what we call the XAI. It explains you why did it, how did it take a decision, what are the variable of importance. If you use a neural network or deep learning type of network where you have more than one layer, you don't know how that final prediction came. This is that part. Mango integration. This is another database. I'm just showing the important ones. The Python integration. So you can write a Python script. If it doesn't support, if that particular work is not supported in KNIME, you can use it as a regular workflow. You don't have to repeat the entire Python library for this. You wrote only one part of that, and you can put it as this. R also it provides an interface, R scripting, R statistic integration also it provides, SAP also it provides. So if you have your ERP data sitting on the SAP, or your forecast that is done in KNIME, you can export it to the ERP for your manufacturing and your production people. That's what it is. All these are the text processing nodes. It supports Turkish, Spanish, German, all these languages it supports. XGBoost and all are various ways to improve the decision tree. It can read red BERT field. This is another type of text classification. BERT stands for bidirectional encoded representation of transformers. They're very sophisticated text mining tool. These are all the extensions I have supported. This optimization is also here. We know all these locations. Now with forecast, I will generate the demand. That location, this much, this location from the warehouse. What is the optimum path? This total demand has to be distributed. That is the optimization, what we call the classic traveling salesman person. It gives you which route the truck has to take. That is also in this itself. And it provides interfaces to both your Tableau as well as Power BI. So those graphic capabilities you can use. It is very simple to build a workflow. I will just open on blank sheet and then show you to you. Otherwise, it takes some time for me to write it. Suppose you want to build a new workflow, you just click this new. We will build a new workflow group. Group means these are the groups. It is like a directory. If there are 15 different projects that are being held, you can keep those workflows for the specific product in a workflow group. There may be 10 customers. For each 10 customers, you will be building different workflows. You make them a group. Workflow group 1, customer 1, workflow group 2. So that all those working in that particular workflow, it can be jointly also they can do. You can share these nodes with others. If they do some editing in that node, automatically your workflow also get updated. That is what we call the collaborative type of work. So this workflow is distributed to 10. Maybe you will be working only on the data pre-processing part. Somebody will be working on the model building part. Somebody will work on the display or the visualization part. So when they are working, each of them will be working on separate portions of this workflow modules. So if he updates, automatically you will get the updated version. You don't have to again tell him, send me the new workflow, all that. That way it supports the collaboration also. It's a very powerful way of building large complex models. I will build a simple workflow. So you put this next. You put finish. So you will get this one. Now what you do, these are the large number of nodes here. This read, write, all is there. So if I want to read an Excel file, move this Excel reader here. Okay. Then what I will do, maybe I have to remove some columns or filter some columns. Come to column, come to filter, take this column filter. So what I am doing is I am not using all the columns for my workflow. So the output of this filter comes here. This is how we make the workflow. Then here you get the help also, what that particular node does. See here, you just click this Excel, you got that Excel reader, what all it is doing, what inputs to give. Now you click this column filter, you get the column filter help there. So you don't have to go to another help file. In some of the systems, that help file will be separate. You will have to go and then read it, then again come back. It will not give you full help. Some minor help it will give you, but not full. This is how we make the workflow. It is very easy to make the workflow. See, you see here, this is what we call a traffic light symbol. So when you see the red, what it means is some input, you will have to give it to this node. After you define the input, this red becomes amber. That means you are ready to go. Then when you execute it, actually the execution take place, this amber will become green. So if this becomes green, that means your workflow has worked properly. If it becomes, sometimes it goes back to red, sometimes it goes back to amber, and you will get a small triangle. When you take this mouse cursor there, he will tell you what error it has come. Most of the time you should be able to manipulate with that error. Otherwise, there is a log file here. There is something called view. Here, open KNIME log. So if you open the KNIME log, that will give you more detail. Most of the time, we don't go to that level. Here itself, it gets corrected. So this is how we build the workflow. I will just open this workflow. Here, what is happening? I have this super stores data. This has been taken from our Kaggle. So I have read it using the Excel reader. That is the first part. So what I will do, I will reinitialize and then run this again so that you will get a feel. What you do, I will reset the node. Now the whole thing gets reset. Now see, all of them will become amber. Originally it was green. Now each node you will have to give an input. The advantage of this workflow is somewhere a developer can do the workflow. You deploy it to production. He doesn't have to touch it. What all he has to do to run it for a different file, you simply click the last button of this workflow. See here, this is where the predictions are coming. So he will click the right band and execute. All the previous nodes will automatically get executed. He doesn't have to come to each node. That is only during the development stage. And you change the workflow or you change the data file. Go to the last point in the node because this is where your results are coming. Click this right button, click this execute, all the preceding workflows will automatically execute. Then the other benefit with KNIME is you can put all your files in a single folder. A part of them can be Excel, part of it can be PDF, we can still read them. It can be CSV, it can be Excel. You put all of them in a folder and then read it. He identifies the extension. And if it is a zip file, automatically he unzips it and then reads it. You don't have to do all that unzipping, reading, all those things. It can read in a folder itself. And there is something called recursive reading. If there are subfolders, you click that recursive read, automatically it reads the folders also, which are below that. So the data I will show you to you. Click the right hand button, come to this configure. This is where you give the input to the node. This is where that superstore data is sitting in KNIME workflows, sample data, superstores. This is where my data file is located. And then here I am seeing table contains the row IDs. That is correct. It contains the column name is in one. You can read part of the worksheet also. Let us say that worksheet may contain your VLOOKUP table or it may contain some graph, P chart and all. I don't need all that. Then you can give the range here, column and then row, how much column you want to read, how much rows you have to read. You can see the preview here. This is how the data comes. There is something called an order ID. We have the order date, ship date. This is the classic retail data. Ship mode. The customer ID is also here. Then where he is, customer name is there. Segment, whether it is consumer, home office, that is there. The country is there. It is all the US data itself. Country is there. City, state, postal code. This is what somebody was asking. Zip and how much is the sales. So all of them are here. And then here it gives you what type of variables they are. So I will read this data, you put okay. Just you execute this. That is a preview. So you can see it and see whether lot of missing data is there or what should we do even before reading the file. Now what you do, you execute this, execute. Now it is reading the file. That green mark came. See, this amber mark became green. That means without error, this node has been executed. Now you can see the output table. Come to output table. That's the output table. So what it has done, that Excel data has been read into KNIME now. These are the different things. City, state, postal code, region, product ID, the category, subcategory, the product name, then the sales, quantity, discount, and the sales. This is our classic way. You see the problem here again. All these are non-numeric variables. Don't build a single model. There is a this is what normally even our students make mistake. They will see the data. This has about some 9,995 rows. So you think the data is enough. There are some 9,995 rows. This huge volume of data. What they do, simply they will build one forecasting model, taking the sales as a dependent variable and time as an independent variable. See here, you have the time here. So he will use only two fields, order ID or the order date will be, it is a time series. It is a daily order, something like that. It is not sorted. I'm going to sort this. This data is not sorted. So it is a daily sales data. So what normally you do is you simply take this and try to predict. No, it will not do the prediction at all. It will go for a toss. Because what happened, all these non-numeric information you totally ignored. You did not use it to build the model at all. What did you do? You simply took the sales and then applied the time series model, whatever that ARIMA or identifying the seasonality trend and all for all these 9,995. No, it will not work, because after all, it depends on the class. Certain states will buy certain goods much better. Region also it has an effect. So unfortunately, you will not take all this. To take all this, you will have to use a tree. So I will use a decision tree first, then do the clustering. For those clusters, I will take the sales and then build the model. That is how it has to be done. This is what I was telling when in my opening remarks last time when I said, see here, you can see the number of columns also here. So there are 20 columns here. It says which are string, which are numbers, what is the upper bound and the lower bound. All these are here. So it has 3 years of data. If you take the ship date from this 2014-7 to 2018, we have 3 years of data. Then your customer ID is again categorical. Your state is categorical. You have this Kentucky, California, Florida, all these things are here. So it gives you some type of an overall picture. And if it is a numeric data, it will give you the mean and other things here. See here, profit. Some places there is a negative profit. It has become minus 6599 and then 8399 like that. The sales is a positive number. So 444, because there was some discounts, that's why the profit became negative. Or some they would have returned. Some returns may be there. They would have taken and then sent it back. So most of the time, stores do not make money on the returns. Probably it would have pulled down. Or some product would have been removed from the market and they would have put on discount. So when you put it on discount, obviously the profit goes for a toss. That's why you see a negative number here. So this furniture, office, all these are there. South, east, west, this is the region. So it gives you the overall idea of how it is. Here what I am doing, since this time series, it was not ordered day wise. We are going to sort the series here. That is the sorter node. See, there is a sorter node here. What all you will have to do is somewhere you will have to pull that node and then simply put it here like that. I am showing for some other node. There is a search also here. So if you put here SORT, it is a sorter node, you put SORT, so you will get sorter here. And the sorter node, you simply put it there. It is very easy. You can do a search here. Which node, if you know first 1 or 2 characters of what work you are going to do, enter those characters here. Automatically, it will tell you which node will do that work. You will get multiple nodes. You can put one of them. To delete a node, you take this right click button and then delete. That's how we delete a node. That node goes off. Just do the right click, do delete. This will go delete. Now this sorter. I will execute the sorter now. Now this is sorted data. We will open the sorted data. It will be by device now. See here. These are all ones. 3, 4, 5. This since it is US, that date has come to the end. 6, 6, 6. These are all the sales on 6. 9, 11, 12. The month is this. So we have sorted the data because for time series anyway, data has to be sorted. So this is the sorter node. Then what we have done, we have extracted the date and the time field from this. I will use it as a variable now. See the date, it read it as a string. Now for my input, for the decision tree, I can use the date and time field also. This is the node. So we are extracting the quarter, we are extracting the month, we are extracting the week. That means I am building a model to do a weekly forecast. That's how week has come here. So you put OK. Now the data will be aggregated now. I just execute the node. This has become green. Now if you see, the volume will be low here. This is aggregated. Aggregated. Now we will do a group by. I have extracted the time and date. Those last two are the date and time. You just see here. Here. Quarter is 11111, month is 1111, week is 2, then it has become 3, 4. See here. See here. This is month number 1, week number 3. Then again it has become, after 10, 11, it will become 12 again. See here, 12, and then again 1. Next year, like that. So these are all pre-processing of the data, some pre-processing. So if you have some missing data here, there is a missing data node. It is very powerful in KNIME. There are 7, 8 ways to fill the missing data. I am not going to show all that today. Then this whole thing, I will be able to demonstrate only one workflow in that case. You just try, maybe next time we will all meet. Wherever you have got stuck up, we will hold the class once again after a month of 1 month or 2 months, so that will be easy for you. Here, I am aggregating the sales. Come to configure. Month and then the week. See, your original data was in days transaction. Now we are aggregating the data to week level and the month level, 2 levels. It is a manual aggregation. So what we are doing is the state region also. If there is some missing data, we will remove those records now, and we will have the sales as the next figure. That is the aggregating figure. This is something like your pivotal tables of Excel. It is exactly that. We are going to group the data, execute. Now you open the table, it will be a grouped data. It has come 74 only, sir. You remember, I have reduced the volume for your demo purposes. Originally, we have something like 9,994 records. I have aggregated to month level and quarter level. It has reduced now. Now I have only how many? 74. Here. You are seeing only 74 here. It is an aggregated forecast that is done by the group by node. We have aggregated to monthly level. Hardly 2-3 years of data was there. Monthly, how much month you get? 12 into some 5. That is what has happened here, roughly 6. So 12 into 6 is 72. That's what you are seeing there. So for your demo purposes, I have done. I will mail this workflow. What all you do is you do a weekly forecast. I am doing a monthly now. That is why I reduced it to 74. Weeks will be more for you. So roughly 52 into roughly 4 years of data, 2014 to 17 or 18, you will have 200 data points now. Now this will display how the sales look. That is a line graph. How it is looking. See the sales. This is how the sales is looking. Somehow you can see here, see, there is some trend which is increasing over a period of time. Some volatility is there in the sales. And what is happening, some type of periodicity is also there. See, between this and this, the gap is same. Between the lower curve, if you say, see here, roughly there is an equal interval. That means some type of seasonal movement is there. Even without going to the model, you can see that one. That is what it is. Now, what I have done to handle those categorical variables, I am building a decision tree first. Now this decision tree will group those cities and then those brands, etc., into a cluster. So that for those clusters, we will build a different model. That is what it is. Otherwise, the tendency is to build a single model. No, it never works. And you don't know what to do now. It gives you forecasting accuracy of 60, 65. And then your boss will say, with my experience itself, I can forecast the demand to 65% accuracy. What the hell you are doing? You throw it to the dustbin. We don't need this model. The mistake you did was you did not do the clustering. You simply took every fellow. The purchase decisions are the same. Volume is the same, like that. That's the mistake. So the partition what he was talking. So I have grouped them into 80-20. We just see here configure. So 80% of the data, I will use it to build the model, and then balance 20, we will validate and then see how good is the forecast between the actual weekly, this is weekly forecast is what I am doing. Execute this node. It will give you the breakup. Out of this total number of records, which is 74 or something, it will break now. So first partition is roughly 59. The second partition is 15. So this 15 is what I am going to validate it. And this 59 is what I am going to build the model. So 59 plus 15 is 74. That is the input here. You can see here 74. You add both of them, it will become 74. Now the simple decision tree learner. So what I have done is I will show you the configuration. Sales is my dependent variable. I am trying to group using the state, region, category, week and month. So let me see whether the sales is more or less uniform across the region, across the state, across the category. Then you get a single cluster. That means there is no variation. Go ahead and build a single model. It works. So if you see a breakup, that means no, there is a big variability in the sales by taking this region, state and category, even week also into account, month also. So let us build a separate model. So these are my what we call the
Sir, sorry to interrupt, sir. There is a Rahul has reached out asking if you can show the group by node configuration once again.
This becomes too big. I will just show it after I run it.
Okay.
I will definitely
okay, Rahul. Yeah, we will
I'm
do
going
that.
to show it. That is just something like a pivotal table of Excel. We have just aggregated the data to month level and the week level. That's all. I will show the node. Then these are all the independent variables. What I am going to do, somehow I feel that single model should not be built for the entire country. So I would like to know the clusters. And this question was asked to me, sir, shall we use supervised, unsupervised? Unsupervised, no, it doesn't take the categorical data. It is tough to do unsupervised classification. I don't know how he wants to do it. It is really difficult. If it is a numeric data, we can use that K-mean, then you have the DB scan. There are so many ways of doing. But when you have categorical data like that, it becomes little difficult. Then there is a way out that is called the hierarchical clustering. That hierarchical clustering also will become approximate because you will have to tell the clustering algorithm how many clusters you want to build. So somewhere if I make a mistake, the whole model goes for a toss. That's why I did not tell him, I did not use it. Now we will run the decision tree. Let me run the tree. You just execute. Let me open the tree and show you to how we get the clusters. I will open this node. You see the average sales is only 31,648 rupees or whatever it is. Now you just come to the right hand side here, left hand side. Now if the week is less than 35, you see here it is 21,235. That means it is less than the overall mean. That means for this segment, you will have to build a separate model. What you do, you put an auto filter here, like in Excel, and separate this data for this cluster first. Because you see the average sale is 31 and for this particular group it is only 21. That means I should not mix, I should not have, I see here it has become 51. So how can I build one single model for this and get the accuracy? No, minimum I should build two. Then again we will click this one. Now state is another variable. See here. So if the week is greater than 35 and the state is one of them, is not in California, Wisconsin, you have one type of sale that is only 21,479, which is less than the average. You come to the other state. So if the state is one of them, all this and this one is in California, that is in not in If it is not in those states, you build the model. And if it is in these states, you see it is 59,571. And you are roughly it is double. See, 31 into 2 is roughly 59. So what this tells is, okay, I am going to build, just for your hypothetical example, I am telling, I will build one model for this and then one model for this. Since the sample size is very small, I will take this and then merge this data there to some extent, because the average is the same, 21 and 21. So you can combine both of them. So build one model for this. Do not build entire model for the one. If you want, you go one more level. It has become 65 here. This is how we use the tree to identify the clusters and approximately tell me how many models I will have to build to do the forecast. This is how it is done. I will show you the prediction accuracy now. It predicts the overall average because tree gives the entire average in that cluster as a forecast. So we will execute the node. Now what I have done, I have forecasted using the tree for the balance records. That means 15. So we will show you the output of this forecast. Predicted output. Sir, this is not very good. See here, 19,577 and the predicted sales is 37. Nearly 2 times. 23,419 and it has become 12,885. See that main tree I used to identify which are the most important variable. So one method is some people will stop at the stage and take the output of that. That is one method. Even here you can improve the forecast. There is something called gradient boosting. What this does is instead of building a single tree, it builds multiple trees and then take the average output as a forecast. So I will just run this node and then show it to you. The node has run. Now let us see the forecast. This is very clever. 22,576 and 22,532. 27,262 is the actual sales. 26,761. And then again, office supplies 15,007, 14,858. So if you do not want to do a time series forecast, this at least approximately gives you the overall demand at this stage. Even without building a time series model. Time series model will refine this one much more. That's what it is. So here I built one tree. A single decision tree was built. And that decision I took it as an output. Whereas here what I did was, I built multiple trees. So when I built the multiple trees, obviously your accuracy went up there. The group by node I will open here. So these are the groups, week and then month. It is the aggregation we are doing. I am aggregating at the state level, region level and the category level. That's why you got less number of records. If it is not there, remove it, then you will get much more. So this is how we use the decision tree when your volume of data is very large to identify the clusters. Then build separate models for each cluster. The clusters are this, what I showed you here. This is how the cluster comes. You can stop it at one level, 2 levels like that. You can break this one, then again it gives you here. 67 here is in Washington. So that means these 3 data, I will take it to build one model, this group. That is how it is done. Any questions are there before I go to that next one? Supriya?
Yes, sir.
Any?
No questions yet, sir. Okay.
One or two I will answer.
Okay. So, taking the question from the last time, predicting from Krishna, predicting the type of investor based on demographic factors of investors, forecasting sales based on time, casual versus non-casual events.
No, that can be done using the tree. You build 2 separate models for that. Already you have you know how much they have invested, their demography like age, profession, income, occupation, where he lives and all. And that can be done. Maybe he may have to build 2 models or 3 models depending on how he gets the split in the tree.
Okay.
What you can do, maybe my email and all, you can share it with them if they have some specific a doubt or something on their data, I can just tell them how to proceed.
Sure, sir. I'll leave your email address in the chat window right away. Yeah,
Yes.
we'll do that. So, sir, okay, now I see a lot of questions coming in.
Let us clear as much as possible.
Yeah, sure, sir. So, Jasmine is asking, is gradient DT prediction on trained data? And since I see the line connected to the top of the partition.
Which one? This one. These are called the gradient boosted trees. This is a way to improve the accuracy of the tree. See here, it has built only one tree. That means it is something like it is 1% decision. Now what this fellow does, it is like this. One tree will do a prediction to some accuracy. Then the leftover, what we call the error part, it will go to second tree. So second tree will try to refine that error. Third tree will try to refine that error. That is what we call the gradient boosted trees. This gives a better accuracy compared to a simple tree. Okay, what I did, the simple tree, I was very unhappy with the results. That means the forecasting error was about 30 to 35%. That I improved it here. And at the same time, I got the clusters for the time series model, which will improve it next level.
Okay, sir. So Ajit Kumar is asking, is gradient learner and ADA or XG boost?
ADA boost is little different. This is called the extreme boosting. There is some little bit difference in the algorithm. They handle the categorical type of data. It is little bit different. Some slight different. The XG boost came after the ADA, what he is talking.
Okay.
He can say it is somewhat a modified version of that.
Okay. Then Manish,
for his question, it has this ADA boost model also. He can see himself and then verify that this works better compared to that. Instead of simply teaching the theory here, you drag that node, let it also forecast. How does it matter? You have this also forecast. Now you select which fellow is better.
Okay. So Munish is asking, sir, how to predict number of clusters based on the input data?
It has grouped, the tree itself has grouped. We have something called the information gain and the Gini index. Using that, it has grouped. This is a grouping. That's what I was showing them. It has made groups here. Where is the tree? We'll open the tree. How it is? No. That will become another class. I have something called the Gini index information. What it happens, let me tell you. This is the overall population. When I split them into two, somehow the information gain of these two should be higher than that. And there is a way to compute the information gain. So if the information gain of the child node is much higher than the information gain of the parent, split the node. Otherwise, it will not split the node. That's how it is done.
Okay, sir. So another question is from Drupal. How to select model for data without only numerical features? The data have no categorical feature. It is a classification problem.
No, it is not very clear to me what he wants.
Yeah, so he's asking, sir, how to select model for data with only numerical features?
You can use this regression tree. This works. It will do the clustering. For example, the quantity sold may be there, then the price may be there, the revenue may be there, age will be there, his salary will be there. So these are all numerics only. So using this numeric, I can find out and it will say, okay, less than 25. And if the profession is senior manager, he will have one type of investment. If it is a junior manager, it will be another. GM, it will be another. Like that you can do. Or even if you remove that categorical, like that profession, let us have age and then the income. And then whatever investment he did, we will take these three variables. We want to group it now. So what it does is, if the age is less than 25 and the income is between this and that, that will become one group. About 25, less than 30, and the salary is between some 50,000 to 2 lakhs, his investment will become second. So the same regression tree works for that. This works. Whatever model, whatever tree I have put, it works both categorical, numeric, combination of categorical and numeric.
Okay. So it is a combination of.
It is a combination. He can use any type of variable here.
Okay, sir. Now the next question is from Madan Lal. So he has two questions. First one is, in this selected data, what is the value of MAPE for decision tree model? Okay, and the second one is
correct. No, I did not. Wait. I did not do it. There is something called a scorer node. So if you put the scorer node, it will give you the MAP. Let me just see whether. There is something called a scorer node. That scorer node gives you that one. What he is asking that. In the next forecast, I will show you that MAP to him.
Okay, and sir, he is also asking also for the second model, what is the MAPE?
Correct. There is something called a scorer node. I have left it here. Let it be as an exercise for these students or whoever is. No, I don't call them students. Who are all the participants? Add that scorer node and get the MAP. There is a method to get it.
Okay.
It is there.
Okay, sir.
Or what he can do, if it is little difficult for him, what you do, there is a maths formula node. So compute the MAP, actual sales minus predicted sales upon predicted sales into 100. So you will get this value. Take the average of that. It will be MAP. What you do, you take this data. There is a maths node here. It will do the computation. So the computation is ABS sales minus predicted sales upon sales into 100. So you will get all these 59 values here, and then take the average of that. There is a statistics node. That statistics node, you take the average of that. That is MAP. If it doesn't have a node, and there is a scorer node, it does. Even if it doesn't have a scorer node, so it will be something like this: 22,576 minus 23,532 square upon what is the actual sale? 22,576 into 100. You get one number here. You repeat it for all the 59. Take the average of that. That is MAP. It can be computed using a maths formula node also. There are 2,500 nodes in this short 1 hour journey. What do you have? How much I can cover? What all I am telling is anything I can be done using KNIME. That is a statement I am going to make. You may have a direct node for that. If you do not have a direct node, we have maths formula node. There are so many other nodes. Using those nodes that can be implemented. In worst case, if nothing is there, write that 2 lines of Python code or R code and then integrate it here and join this node to a Python script node. It works. That's all. You write that node here, Python script node. There is a way to do it. Then join this line to that Python script node. Then the Python script node will compute your MAP. There is no issue at all. Some small work you may have to do instead of writing the entire code for this. Or writing that Python, what you will do, import KNIME, import pandas, import scikit-learn, import stat dot, import decision tree. That all imports will come, some mismatch will happen in that error versions, version number, some fellow will update one version and another fellow doesn't get updated. He will handle all that. It creates what is called an environmental variable. For each project, you create an environmental variable. Only those versions will be there. And even on your pip or conda, some other version get updated. It will not automatically update, so that your workflow continues to run.
Okay. Sir, Jasmine has a question. Is the first approach of decision tree building a cascaded model followed by one forecast for each cluster?
Correct. I have done the clustering.
Okay. Then, sir, Ajit Kumar is asking, should not the gradient predictor tree taking data from validation set?
Correct. I did not write it here. It works. What all he has to do is gradient boosted tree. You copy the node here. I will show you how to do it. Put this paste. This node has come. The model is the same. It is the same model we are using. Join the model node here. See, somewhere it has got un. Let me clear. So the learner will come here, or I'll put it here. Sometimes you will have to arrange these icons. If the length is large, sometimes it does that. You will have to join this node to this node. And then finally, this node has to be joined there. You join like this. And then this node will go there. Somehow it is not going, it works. You will have to join this node here. That's all. There is a way to join. You will join this one there. Something got stuck in this workflow.
Okay, sir. Or maybe we can come back.
Correct.
Later, sir. Yeah.
Correct.
So other question we have is node 99 is connected to train split. I
Correct.
think the prediction is on train split.
Correct. No, this is on the validation. That's why I joined this other part here. What he is saying is correct.
Okay, okay.
Now
And
what you do, you join this validation part to this, and this model part you put it here, then it works. Maybe let me delete and then see whether it works. That one connection is gone.
Okay.
Now you try to join. Something is there. This diagram has got stuck. You will have to refresh it and then run it. I have opened so many workflows. You know, there are 9-10 workflows opened here. That is why.
Yeah, might be because of that it is on.
Correct.
And sir, we can come back to this later.
Yes,
Again,
yes.
the question is like, I think again, sir, please show group by node config. I am stuck here. How to give a group by condition? Someone is asking.
Here. We will send the workflow. See what happens. I will send this data as well as the workflow. He can open each node and then try. Otherwise, I will not be able to show this deep learning at all. We have not even come there.
Got it, sir. Got it, sir.
Other part, I am just keeping quiet. This is our classical model I am showing. Where we came to deep learning. Deep learning is totally different. I have not even reached there.
Yeah. Sir, then another question from Ashish is, what is the input to gradient boosted trees learner node? Is it the training data with 59 rows?
No, to build the model, it is 59. And for the validation, it is 15. So what you do when the model is built, this output of the model has to be joined here. This output, this line. And then this line will go as an input. So what it does is on the trained model, it will apply it to a new data here. Here.
Okay. Then, Sir Srinivasa, I don't know, it's a question or he's making a comment. Connect node 98.
Node 98 to where?
I think this is an incomplete question, sir. So we will come
node
back to this
98
later
is
on.
connected. I'm training the gradient boosted tree. See, this is a simple tree. So the same data I'm putting it here. Then for that tree, you will have to join this another node here.
Okay. So, sir, we have covered all the questions, and now there is a time for another break.
Correct.
In 4 minutes. So, shall we take the break and come back at 12 o'clock, sir?
Yes.
Okay.
Yes.
So, we'll see you at
Arima.
Yeah.
I will show the Arima in that next group.
Okay, sure.
Yes.
So participants, please be back by 12 o'clock. And also I will leave you with the link to the survey link. So meantime, you can start providing your feedback on the workshop.
So this I will show next time. How do we identify seasonality, all that in this?
Sure, sir.
Again, the same, that superstore data only. I have done it for the entire data. I want them to do it for the cluster. Then they will have to repeat this workflow. I have done it for the entire, that 59 points are 60.
Okay, nice, sir.
Shall we start?
Yes, sir. We can.
Okay. So that earlier workflow I showed how to group the data. Now here what I am doing is this part, you will have to repeat it for each cluster there. I have taken, for your demo purposes, I have taken the entire data just for your show. Otherwise, you will have to repeat it. Those 3 clusters or 4 clusters I showed. That has to be built. Here again, it is the same data. I have read this super sales. We have sorted the data. So here what I have done is, in a day, there may be 40 transactions or 100 transactions or whatever it is. I am aggregating it by the day. That means what has happened here is, for the entire day, I have a sum here. So I will just show you this group by node. Probably it may be clear to him now. Configure group order date. So what it does is, in a single day, if you have 20 transactions or 30 or 40, it will group it. That is this order date. Then there is an aggregation here where we sum. Sum is the function that is used. So sales. So I am aggregating this sales day wise. And then what I am doing, I am trying to build for your demo purposes. Otherwise, it takes a lot of time for me. I am building a single model for that data. That's all I am doing here. That's why we are not grouping it. So in real life, what you have to do, your earlier, what is that? This model, I am able to join. I have just joined here. The tree had got struck, so I refreshed it. It is coming here. So here I am saying the gradient part. So don't use this data for prediction. Prediction, you will have to use this one. So the data, for separating the data, we will use this model. For doing the prediction on that data, you will have to build this workflow again. So you don't have to build the workflow again. What all you will have to do is this a group by node only will change. That's all. Here you will have to change the file. So what will happen as a demo? Let us assume you come here. We will run this tree. Now I have the tree here. Now assume that I will build one model for this part where it is very high. Something like this. There is only one sample, you leave it. You take this part. So it will have 51,000. It is much higher than this. So what I am trying to tell, this 20 is there because it is aggregated. It is very small. When I do it at the daily level, this number will increase. So for this group, you put an auto filter and then segregate this data, build this workflow for this group, and then another workflow for this group because this also has 39. 39 because it is aggregated at the monthly level, it has become less. When you do it weekly or aggregated at daily, this number will become large. Then you may have some 2-3 models. So what I am trying to tell is you use this decision tree to identify the clusters, something like 1, 2, 3. Now, after identified the cluster, you know this data. So you put an auto filter. There is a filter here. There is a row filter here. In the row filter, you put these conditions greater than 35.5 week. Then only that data you get. Now that will become an input for this workflow. See, instead of reading this Excel reader data, this input will go there. Behind that, the tree will come. After the tree, you will have a row filter. That row filter, what it does, that row filter takes the data for these segments. For this segment, it will take. Then this workflow will continue after that. From here, instead of that, behind that, the tree will come. So after the tree, one more row filter will come. Then you can run the entire workflow till the end. That's how it is done. So here for showing, I have grouped all these clusters and then taking them as a single thing. So that's what I have done. So this group by is simply grouping the data. Sales, it is grouping by date, order date. So if there are some 30-40 transactions in a day, it will add all that. And then you will get single record for each date, for all regions, all customers, all products, all brands. That is all that is happening now. Whereas the tree, it gave you a broad cluster. That is the difference between these two. Then someone was asking that K-means cluster shall we use? What is happening in the K means you have only the sales, you have only one variable here. So it will not give you, if you have more variables like age, those type of things, maybe it is worth doing it. So group by. Now here what I am doing, there are some missing days here. You just see, let us open this table. Now somewhere you can see after 7, 9 has come. There is a missing date here. See, after 7, 9 has come. 10, 11, again 12 is missing here. See, after 11, we don't have data for 12. So 12 is missing. Then after 16, again 17 is gone. Then somewhere, again there are few missing points. It will automatically identify here. See, we have written what is called a component. Now this component will identify automatically where that missing date is there. How do you do it in Excel? Almost all of you are experts in Excel. This is little difficult there. How do you identify a missing date? Okay, identification I may do it. I may subtract tomorrow's date from yesterday's date. If the difference is 1, it is not missing. And if the difference is 1, it is not missing. If the difference is more than 1, date is missing. Agreed. Then how do you insert a new row there in Excel? See, because the date is missing, I will have to insert a row. That becomes tough doing in Excel. This component will do it automatically. So I don't have time. So I will just open the component and then show you. These are the dates it is missing. He has put question marks here. That means there was a missing date. That means it was violating your time series assumption. In between, there were some missing values. All these question marks are there. It identified. This is little difficult in Excel because it may be 3, it may be 4, it may be even 2. Now, if it is 4, you will have to insert 2 blank records like this because 2 dates are missing. Then sometimes, unfortunately, if it becomes 3 or 4, then you will have to insert 3. If it is 1, you will have to insert 1. I don't know. I will leave it as an exercise because I don't know how to do it in Excel. Nor I want to use Excel for this. This is where some of the limitations of Excel comes. I will simply use this. Otherwise, it is a little tough. You will have to insert here 2 blank rows in Excel. And then here, you will have to insert 1 blank row. Here again, 1 blank row. Then again, some blank rows here. See here, 2 rows. I am a little bit unfamiliar how to do it in Excel. Maybe, I think by writing a macro, I think we should be able to do with normal command. It becomes a little bit difficult. Then what he is doing, he is filling the those values to be a 0. So wherever that question marks are there, you will get a 0 there. Here earlier the question mark was sitting. Here 0 was there. This is not the recommended way. What you have to do is I will tell you. That you can do it as an exercise. I will take this stamp. What you do here, you take the moving average of some 3 days sales or something. What you do, instead of putting a 0 here, it will be average of 55 plus 11 plus 19. That will come. You can repeat it here instead of putting a 0. Then here again it is missing. What you do, you take this and then this, put the average here. Instead of putting a 0 here, that way it will be a little bit better. Again here same thing. Here also it is missing. You have filled this with missing. Then take the average of these 3 fellows and then repeat it here. There are other sophisticated ways of doing it. It is available in KNIME. There are 3-4 methods of doing. For your demo, we have put them zeros, but that's not a good way. He has all filled it with zeros here. See here there were 2 question marks. He filled them with zeros. That is little simpler to do it. He did it. Then what you have to do, there is a separate node called this missing value filling node. So there are different ways of doing it. That's what you will have to do here. He has simply put a 0. Do nothing. So we have other nodes here. With that, you can do the previous 2 days average, 3 days average, or you can fit some linear interpolation between those 2. A small regression you can do. I will just show it here. Where was that missing? Here. Wherever these 2, you do some type of a small regression. So you fit a small straight line between these 2, you leave it. Then another few points ahead, something like 8, 9. So we are going to fit a line for this, then you get the equation to the line in the form of y is equal to mx plus c. To fill it, you put x is equal to 68, you get the value here. Well, you put x is equal to 69, you will put the value here. That can be done here. Doing all this in Excel will be tough for you. How do you do all this? What we call the local regression. It is called a local regression because I am not doing the regression for the entire data set. I am taking some few people behind, a few 5-6 point later, and then trying to get the slope of the line and then filling it. So that is how we have filled the missing value. For your for your demo purposes, it is a 0. Wherever sales is not there, we have put them by zeros. That's all that. And that is why this table will be larger than this table. See here, I have only 1,237 rows. And after this, it has become 1458. That means so many missing was there. The missing was 1458 minus 1237. That is the number of missing values it was there in the data. Values mean the date was not there. It was skipped. One date was skipped. Sometimes 2 days were skipped. That is what it is. This is a huge file. What I have done is this is a row-based filter. For your demo purposes, we have taken 1 year of data here, only 2017. Here it was all. It was more than 2017. So in a row filter, you can fit the date, the starting date, that's the ending date. So we are going to take 1 year here. Starting date is 2007 January. You put 1 year, we will get data up to December. That's what he has put here. Otherwise, it becomes large. It will take a lot of time. In these 2 hours or 2.5, it becomes difficult for me to cover. That's why we have taken this. I will show you the line plot for this 1 year after putting that, taking the data, how the sales looks like that. That is how it is. Daily sales, see here, daily. This is how the daily sales is looking. For forecasting, we are aggregating it. Daily sales is very volatile. That's what I was telling, we don't do it. Then here what we have done, we have aggregated to monthly. So the data has become monthly here instead of daily. Here, in this component, it has happened. I will show you the graph of this now, how it looks like. This is how the monthly data looks. This is what we can forecast, not that data. You will not be able to forecast using that. What do you forecast? It is all something like a random number it looks. See here, we have aggregated. This is what I will show you the forecast. Now, you can see some type of a trend here. It is more or less, there is some type of a growth in this. If the trend is not there, it will move around the horizontal line. It won't come like this. There is something like a trend here. And some type of seasonality is also there. See here, these two peak and these two peak, the gap is more or less the same. You just watch this down between this and approximately between this and this, this and this. That means some type of seasonal pattern is there. And at the same time, some type of trend is also there. There is an upper growth here. See here, the average here was only 1200. Somewhere when you come here, it has shifted to 3000. Just by visual inspection, you can make out that some type of trend and then seasonality is there in the data. So here what we have done is we have extracted the seasonal pattern. This is called the seasonal decomposition. So we have removed the trend part. We have removed the season part. So the trend part you can do 2-3 ways. One is you can fit a linear regression and then do the trend. The second one is we can put some type of a quadratic trend, second degree curve. So y is equal to something like A0 plus A1 into sales plus B1 into sales square, something like that. That will become a second degree curve. Now, that is what is the trend part. The season part, what happens is always something like January sales is low compared to February season or March, like that. So what we do is we take the overall average and divide it by the quarter or the monthly sales of that. It gives you what is called a seasonal factor. So that material, whatever material will circulate, those details are there. That is what they have implemented here. There is nothing new in the workflow. They are there in that theory part. So after extracting the trend and seasonality, this is what is a decomposed signal is. I will just show you the graph. See here, this is the trend part. That is it is not a linear trend. It is something like a small quadratic trend. That is what you are seeing here. And this is the seasonal pattern. See here. The green part, this red part is the season. Now this green part is the residue. See here, you are seeing some residue in the green. That is more or less random. So what we will do to forecast for any given future, extrapolate this trend line. We know the equation for the trend. So it will extrapolate beyond this. That is the trend. And you know the month. So depending on the month or week, I know what is the seasonal sales. For that, add that. Now there is a leftover part here. This leftover part, it is little tough to forecast using these simple models. There are two ways of doing this. One is for this leftover part, we will use deep learning to forecast. Because this anyway I could forecast using the simple model. So take the output of the simple model. So I know when I extrapolate the trend for the next quarter or next month, what is the likely value? See, this trend line gets extended here like that. Now that is the trend part. The season part also I know. Which week we are forecasting, we know, put that week here. This graph I will get. So these two I got. Now this one is difficult to forecast because it doesn't have much pattern. Since the season part and sales have been removed, I am not left with. This is what we call a random pattern. Now the random pattern, we can build two models. One is using this ARIMA model for this. So the rest over part, we will forecast using this. And your actual forecast will be summation of trend plus season plus the leftover forecast. So this ARIMA model, there is some issue with this. Something I updated yesterday, has some version number, there is a conflict. So I will correct this one and then send. The next part is this leftover part, what I am showing. This series, we will input it for the deep learning. That is able to extract these type of components into that. That's what it is. This leftover part, you can feed it to that. That will do the forecast of this, how it will go like this. Then we add all this. That is how we do the forecast. So this green series, we can use the deep learning. Because with this ARIMA, we are not able to predict. ARIMA is one, it will predict it to some extent. And that deep learning is one. There is something called the numeric outliers. This is what I was telling. How do we remove the outliers like that? So before using the ARIMA, some outliers we have removed here. This treated table is here. So some tables we have replaced here. This is the signal, this is the original signal, this is the trend part, this is the season part, and this is the residue. You see here the residue. Now this residue is what I am trying to forecast using either using the deep learning model, or we will use this ARIMA model to do the forecast. Then you add all of them. Trend plus season, plus there is another thing here. There is season, there are two components here. Another one is a zero. There is something called a quadratic season trend and normal trend. For this, you don't have that other part of the season. It is a simple seasonal growth. So you add these two, plus for the residual, we will forecast now. So you add all of them, that will become the signal part. That is your original signal. It won't be 100% identical. Some error is there. That is the forecasting error. And what I was telling was the mean absolute percentage for that error should be about less than 10%. That's what I was telling earlier. Up to this is clear?
Sir, there are three questions if you'd like to take it up. So I think from previous one, somebody is asked, okay, Srinivasa is asking, instead of trying to connect node 95, which is not connecting, because that model is decision tree, not GBT. I think that's a statement he's making.
Yes.
Yeah.
I didn't correct.
Yeah. And then Jasmine is asking what happens to other categorical variables which are not a part of the group by criterion which we perform group by.
No, this is a separate model that they have to do. What has happened? The categorical variables have to be taken care in decision tree. We are not going to include again categorical variables here because already the tree has done the clustering. So the numeric part of the component only comes here because all these models cannot handle categorical data anyway. Categorical data has to be handled in this part. Where is that one? Superstore decision tree. Here you will handle the categorical part. You see here the input configure. All categorical part I have taken here. So we use the tree to group using the categorical variable. Then some numeric variable is also left here. There is some cluster, this numeric part. There are about 29 or 39 data points here. Now this numeric alone is what will go to this model here. Instead of the Excel part, that numeric will come here. Then after this, it is all date and numeric only. We don't take any other information here.
Sir, then Sarma is asking, could you suggest a book for interpretation of results, graphs of forecasting?
That forecasting book I will send. Yes, it is there. Okay. Markadakis book is there. There are another one or two. We will send it. Books, there is no shortage. There are 2,000 books in forecasting. I will send them the lowest book written for practitioners, which has about 200 or 180 pages. Then KNIME itself, there is a community in KNIME. There are blogs are there. Then the KNIME community is there. And lot of this information is there also, who have put the feedback, how to interpret all those things. We can go, it is free, membership is free. You enter your email ID and then put a password there. You can access the KNIME blog. You can access the KNIME community also. So if you don't have any workflow, you put it there that this is the problem. If somebody has written the workflow, they will give a link for this. You use that workflow. Simply you change the data file and then start running. That's all you have to do.
Yeah, that would be great, sir. So we will share all the materials with you.
Correct. You tell him there are 2,000 books. I will send him only 1 or 2 books. He doesn't have to get scared. Yeah. And if somebody wants to do a research, that is what I was raising earlier. See, all these models, they are not taking your news, sentiment and all into effect. That is what I was telling them. That has to be incorporated as an additional variable. That I did as a separate class. That outcome has to be merged with these models. That will become the total end-to-end deployable forecasting model. Neither that one alone nor this one alone. This will not work. This works if they are very lucky. It will work. If they are somewhat unlucky, and if that news plays a major role rather than these numeric numbers, then how this model will give you, because you have left out the information which was supposed to, which is playing a role. We have left out because we did not take the sentiment or the emotion of those news into effect. That also you will merge here. That is a deployable model. Then you put that XA and all that explains which variable, whether news is important or season is important. So depending on that, you can delete that variable and then rebuild the model again. Then deploy it. On an average, I can give it may sound a little bit joking. If you take 1 month to build the model, minimum you take 4 to 6 months to deploy.
Deployment phase is quite long.
Oh, no. There are a lot of issues. Some fellow will not agree. Those salesperson or the director sales will come back and say, no. This is all rubbish. I am not happy with that. What has happened? The variability in the data has changed and somebody forgot to update the model manually. When you do it manually, there is something called auto deployment that is also available in KNIME. They will take a separate session altogether. That's why. At least let them learn the fundamental first, so that next time when we do some advanced method, we will send the invite to only these participants. Otherwise, again, if I bring new one, again I will be back here only.
Yeah. So this will be that will be a continuation.
Correct. Maybe after 1 month or 2 months, we will hold another class where we will tell them all those things, whatever is left out. Correct.
Absolutely, sir. So Prasad is asking, when do we do addition and multiplicative models?
The seasonality model that is shown here is an additive model he has used.
Okay, sir. Then
wait. Multiplication is also there. Then what he has to do, I will show you how to change there. What you do, right click this button, come to component, you open the component here. That is the expansion of that. See the number of nodes here. Now somewhere it is an additive seasonal model that has to be changed. All these were hidden in that one red box. Oh, otherwise it becomes too long for me to explain. That is called a component. That component is hidden of this. You just see here. This one red box, here, this red box is not a single node. When you see a red here, it means it is a component. What it says, it is a group of nodes. Now, how to open this? Right click this one, come to component, open. That's the expansion. See here, that's the full thing we did in that red dabba. Here you will have to change that node. Again, you do the expansion of the, it is much more. Come to meta node, open. So here we will have to change all that. Here that model will be there. That additive seasonal model will be there. Each of these boxes will get opened now. Otherwise, it becomes too difficult for a presentation. If you go to your general manager or director sales and all, you keep on opening those, what they will think? They will say, what is all this happening? So what we cleverly do is we merge some of these nodes, which does a complex function. This is called what we call a component. There is a way to convert those nodes to a component. We will cover it at some other time. Then you get this red box. Now this red box hides so many hidden nodes from the external world. And there is a dialog also. When you click it, you can fill all these like a user interface. Order date you can change, sales, some other figure you can put so that it becomes a GUI and you don't have to touch all those nodes at all.
Okay, sir. Sir, Prasad is asking, in which situation do we use additional model and in which situation multiplicative model?
I will tell. Let me see this. Where was that line plot? We plotted that line, the trend, seasonality, some trend. I had put a graph. I will take one graph. Let me see. Let us see. I think this was the graph I took. No, this is actually sales. Somewhere here, decompose the signal. I will show it here. Correct. Decompose time series. We will show here. See the trend here? This is more or less linear. Then what will happen? This purple line, what he is seeing, if this goes line like that, see, you just watch my mouse arrow. I am starting from here. Slowly, I am moving slowly, deviate, something like this. It goes there. Then it becomes a multiplicative trend. It is virtually, it is a horizontal line. There is not much change in the slope. So if it is a multiplicative trend, this graph will look something like that. It goes like that. Then it will be a multiplicative model. Then he can come back, open that component, and then change that to multiplicative node instead of that additive node. That's all.
Okay. So, sir, Jija is asking if we can do multivariate and multi-step prediction by KNIME.
There is a multivariate ARIMA in KNIME. For the demo, I have not taken. I have taken only single columns like sales and date, and that can be done using deep learning also. What I am showing for the demo is what we call a univariate ARIMA. There were only two columns. One column was the date. The other column was the sales. Now, there may be numeric variables like the price of the product, another numeric, and there can be another indicator variables like whether the promotion was on or whether the promotion was not on during that. And if he has some competitor price, he can put the competitor price. Of course, if I go to a departmental store, I can see Himalaya brand also, Procter and Gamble, I can see Nestle also. Where is the problem? I can pull out and then see. I will always get it. So now that becomes what we call a multivariate ARIMA. So multivariate ARIMA, there are separate group here. I am not showing it today. See, somehow it didn't work. Some upgrade here, here. There is something called the ARIMA learner. Here it can be done. This box. That is called multivariate ARIMA, where you have more than one numeric variable like sales apart from the date. So you will have date also. Now the date will be split it into month, quarter, and then year or something like that, or it can be week and then month. Then you will have the product price will be there. Then there is an indicator whether some discount was there given during that, or some sales was there, or some promotion was there. And you can also have an indicator like whether it is a festival season or a non-festival season. These are called the indicator variables. With all the indicator variable price and the sales, we can build a multivariate ARIMA. That is ARIMA if you are using time series. And if you are using the deep learning, we can also, you input all those into a deep learning model. There also it takes numeric. See, the basic issue all of these participants have to understand is, use the decision tree, use non-numeric there. Because none of these models can handle non-numeric properly. Even if you hand it, as some of them said, huge number of tables, it will build columns, it will create, it will all be 1 zeros most of the time, and it becomes an inconditioned matrix. You will not be able to estimate the forecasting model parameters. It will all become haywire and goes for a toss. So use the decision tree because it is very powerful to handle non-numeric data. Then come back to this numeric model, put an auto filter there to filter all the numeric data to these models, and then proceed with the model building.
Okay, sir. We have another 2 questions left.
Another 2, then I will show something different now.
Yeah, sure. So one question is how to decompose the signal. What is the correct way to decompose, and should we be aware about any parameters for this?
No, parameters he has evaluated. There is something called a additive model, see a multiplicative model. These are only the 2 ways to decompose a signal. Those nodes are there in KNIME.
Okay, sir.
Additive model, what it does is it will say the sales for this is some constant plus a linear trend plus some error. That is your additive model. The multiplicative model, it will put second order season also for that. So your sales will be some constant plus linear growth plus, if it is linear, otherwise it will be non-linear trend. You can do a second degree regression, it does. Then seasonal component, it uses what is called our good old Holt Winter method. That is what it does to decompose the signal. And the leftover part, we can use it for ARIMA, for that balance error, what we call an error. After building that either multiplicative model or additive seasonal model, still you will be left with an error, which those models could not predict. That part you input it to this ARIMA. That's what he is doing here. The leftover part he has taken to ARIMA. See here. After decomposition, he has taken what is called that leftover error. That's this last part. This is what he is inputting to ARIMA, not those 2. Those 2 anyway got identified by your earlier model. He could separate. Now that last leftover part has come to here. You see here, after removing the outliers, he has taken it to ARIMA modeling here.
So, sir, Mahesh is asking to describe the significance of residuals as to why we need to consider it for prediction using deep learning.
Because that residual could not be removed by your simple model. Let me put it that way. We started with a simple model, like either additive seasonal or multiplicative seasonal plus the trend. Unfortunately, what happened most of the time, if those simple models are able to give me a forecast, why will I go for the complex? So the leftover part, what it means, it is an error of those models, which unfortunately those models are not capable of removing the error. And since the ARIMA model is little bit complex model, it will remove that error. That error gets forecast a little bit better. Part of it will make it, and then add it to your previous people. That's what it is. See, there are 5 people in a room. One man does not know the regression. You give him the data, he will give you regression and then give you that output. So you take the residual. You give it to the second person, Are Baba, he doesn't know any one of these. This is all he has forecasted. The difference is what I am going to give you. Let me see whether you are able to improve this series. So he will take that seasonal part again. He doesn't know how to handle this error. So you give it to third person. No. Those two people have already handled some part of this forecasting. Now they don't know how to handle this part. You handle this. That is all he is doing.
Okay, sir. Then I can see just two more questions, sir. After grouping the data, okay, now there are more questions coming up, sir. After grouping the data from decision tree model, I think we have already taken this.
I have answered
yes,
that you bring it here instead of Excel file.
Yeah,
that data will come. See, there will not be Excel reader here. Where is that part? Now this cluster data will come there. I will just open this tree. We will see now this cluster, we can extract the data of this cluster. That is what will go in front of this. There is no Excel reader in that case. It will directly come here from the tree. Now your workflow of the tree will be preceding this workflow. It will be something like this. Now you can group them and create this red type of box here, so that when you give a presentation, they will not see this entire workflow here. This whole workflow can be made into that red box, the entire flow. So when I come here, you will not see the tree, you will see one red box here. Now that red box will feed it into all these models now.
Okay, sir. Sir, Jasmine is asking, are we essentially boosting a simple model with ARIMA or DL?
Correct. We are boosting. We are boosting. Exactly.
Okay.
Is correct.
Okay. And then Krishna says white noise can be modeled using GARC. I don't know what he's trying to say.
No, white noise, it is difficult. White noise means it is something like a random walk. Let me put a joking question to him. Can we predict the path of a drunkard? Yeah, sometimes he comes to that path and immediately he goes in the other side. Where is the model? So random walk is something like to predict the path of a drunkard, which is tough to do. It is called a white noise. To some extent, yes, using the deep learning, we can try to do it, but there is no guarantee. That is what we call the leftover error. What it means, the process that generated the data is little complex and somehow we are not able to handle. We have to live with that, or create some additional variables which can remove that noise. These are the only two ways of handling it.
Sure. Okay, sir. So, sir, we have another 10 minutes before we take a break. So, we can continue for 10 minutes and take the next break at 12:50.
Yes. So, that's what it is. I will show another workflow here. Something where I will show this. This includes all. So there are three boxes here I am showing. So what it does after doing the forecast, see, this forecast is only one part of the journey. After doing the demand forecasting, somewhere it has to go back to the production. So that production data will have what is the stock left in hand, what is the reorder level, what is the safety stock, what is the reorder level. Then it will place an order automatically when it falls below the reorder level. That is this workflow. This workflow, I will not be able to explain completely in this. I will little bit partly explain. See, those models give the forecast. Now that is only one part of the journey. So what we do is, in the real life, some X forecast it gave. Then what is happening? We have something left in stock also. And this order, we don't order one product like that. Then it becomes, your order cost will become very high. So what we do, we aggregate. Let us say these 200 stores are spread in my country, and for product number 1, maybe in Bangalore, it may be 90, then Chennai, it may be 32, and somewhere in Hyderabad, it may be 47 or something like that. So I aggregated and got the demand as some 140 or 150. Now we are not going to raise a order for 36, 20 like that. See, we aggregate because then the discount I get when I order it at a larger quantity. So what we do is we aggregate for that 120. Then that 120 comes, we will distribute it to these workhouses. Now there is a problem. When I aggregated it, what happens is there is an uncertainty in the lead time. It may not come here. He may need it in a week or 3 days. But when you place it at the order level, it may come after 4 days or 5 days. Then the safety stock has to be kept during that time. So there is something called the uncertainty in the demand. The uncertainty in the demand, we are trying to improve our forecasting and then do it. There is an uncertainty in the lead time. Now this lead time is an integer, something like 10 days, 7 days, 4 days, like that. So this has to be modeled as a Poisson distribution. Now this is combining all those things. There is an uncertainty in the demand. There is an uncertainty in the lead time. This is something like combining the variances. If x1 and x2 are two random numbers, the combined variance will be sigma 1 square into x1 square plus sigma 2 square into x2 square. All that he is doing here. Now, and then again, that aggregated order, he will break it down into your stores level or something. That's what it is done. I will just open this component and then show it. Maybe in some 10 minutes. 10 minutes is not enough for this. It will give them some idea. It is not that simple in the real life. Develop some model and then put it there. Nobody will accept all these things. It has to feed back to the system. So the forecasting model will do the forecast. Now that will go back to your inventory management. Now it will go back. Now there they will know what is the safety stock in hand, what is the reorder level, and how much we should reorder, because it may not be done at your store level. We may have to do it at the warehouse level. So we aggregate the demand to the warehouse using the stores level forecast, assuming that we have forecasted at the stores level, aggregated to the warehouse, that because that one warehouse may be supplying some 40 stores or 50, aggregated to that. Now we know what is the inventory there. That inventory will be some of these inventories he will manage. Then the reorder level is also known there. Then there is something called the economic order quantity, what we call the EOQ. That EOQ is what I will order. I will just open this. Just I will show it to you. The component, you just open. This is the expansion of that. See here. Now what happens? Nobody is sure that 100% component we can predict. So what we do, we put what is called a confidence level here. This is what is called the Z score. Now what I am doing, so you see here, the Z is increasing. As you increase the Z score, the probability of this out stock becomes less. So what happens if you set this Z score to 91, that means almost 90% of the time you will get the goods. 10% of the time you may run a shortage. So you set the Z score in this component. Those books will tell you. I will tell those books. They will tell you how to do it. And if the Z score is low, see, if you set Z to 55 or here 60, that means 60% of the time only I am sure that demand I am able to get that. It will not go beyond that safety stock. So this is the Z table. He has created the Z score here, and this is the p-value here. 50, 51, 52. For almost 99, your Z will become 2.3. This is your 2.3 sigma. This is a normal curve. So then 1% of the time only you will run the shortage. That is what this table is. Now this table will be merged with the demand table now. That is how it happens in real life. And that is how we get the reorder level here. I will show you here. Some tables I will show. So we are setting the 92% confidence. That means 8% of the time I am able to, it is all right. Even if that goes out of stock, I don't mind. They may be low value items. So it's all right. So I have set the Z score to 1.4. So Z score of 1.4 translates to a confidence level of 92. That is what I have done in this workflow. It can be changed. And the table, you can change it. Now this is where I have read my data. Is it? This is a little bit different data. You can see the warehouse here. Here, warehouse 1, warehouse 10, warehouse 2, all these are the warehouses. This is the product. This is a safety stock. So I should not go beyond 26. This is the reorder level. These two are not the same. See what happens if I reorder for this quantity, the discount will be more. That's why I'm going to reorder at this, not 26. Now again here, the safety stock is 62. The reorder is 142. Now here you have the current demand. Here. See here. Current inventory is this. If we will filter this table, then there is the average inventory. Average demand is this because he has taken it monthly. This is the standard deviation of the demand. This is where that Z score comes to do a prediction. This is the maximum demand, minimum demand, average lead time, how many days it takes to get it, and the lead time variability. There is a variability for this also. This is a Poisson distribution, and that is the normal distribution. I will just go through this workflow. It will give them some idea. Obviously, this whole class cannot be done in 4 hours. That's why I was telling we teach it minimum at least some 2 days or 3 days. Then it will be more clear to them. There is a maths formula here. I'll show them some output so that at least it gives them some idea how it happens in real life. That Z score, I have set it to almost 90%. That means 10% of the time it is all right. Even if it goes out of stock, it won't get affected because anyway in the production schedule we put a slack to take care of all these things. So even though I am telling that if all the paths in the production work, the delivery date may be some 12 September, some 2022. So for a customer, I will not order it I will not give him the date of the 12 September 2022. We will give him some 30th September to take care of these uncertainties. That's how the salesperson has to give it. So I will show some tables here. I'll filter table. This is what it is. One product only and one warehouse we have filtered here. See that at so many warehouses and then 6. So we have taken 3 warehouses, something like 4, 6 and 8. And then one product, that SKU 05, SKU 02, SKU 01. Safety stock is this. Reorder level is this. Current is 30. That means I will have to place an order now. This one. Shall we break now for some time?
Sir, we have another 2 minutes left for the last break. Please let me know when you would like to take a break.
Okay. So that is this part. So we have identified what are all we have taken 1 or 2 warehouses in this. That's why there is a row filter here. And just open this component. This is the expansion of this orange box. Whatever orange box you are seeing inside, it contains all these nodes. So we have put a row filter here. In this row filter, we have taken only 1 or 2 warehouses like that. Here. So we are not taking all the warehouses here, that whatever 3 I showed you. Eventually what we did was, we identified what part has to be reordered here. These are the 3. Otherwise it becomes too big a time to show all that there were some 20 warehouses, so many SKUs. That is your original data. Here. This is your input data. What I showed you in that box. This is the data. Total. Not here. There was an Excel file he read. Here. This is your original data. We have something, all this is there. In this, certain part of it only we have to reorder, depending on that Z score. I had put a 92% confidence level. If you go by that, These are the 3 or 4 items which we have to reorder. That is finally what he has done in this workflow. This is what we are going to order. Out of that 59 or something, we have reduced it to 3 rows. Originally, there were large number of rows here. 50. 50 has become 3. What it means is, as per our confidence, there is no need to raise a purchase order for all this. So 3 is more critical for this. Those 3 is what you want to order. That's what it is. Any questions so far?
There is one question, sir, from Surya. What are the system requirement for data with 20K rows and 10 columns in context of prediction workflow?
20K rows means what? What other information it contains? Is it a single site or single warehouse or SKU? Because we don't do the forecast at SKU level sometimes. We do it at the group level. Then we divide it for the SKU level. We know, okay, 30% of the SKU1, SKU2 like that. That is how it is done. If you take Flipkart or Amazon, there are some 20 million SKUs. How will you do the forecast? They don't do like that. What all I am saying is our KNIME gives an interface to your big data. It can take Spark. It can take Hadoop. It can take one more. So probably we will have to do it there and then host it on a server like that. Either it can be on a cloud, cloud services, or KNIME itself has a server. So if you want to host it on KNIME, some small amount they will charge. So if you host it on some other public servers, no, you don't have to pay any money. What all I can tell is, yes, it can handle some few millions of rows. There is no shortage there like that. How do you cluster them? How do you group these warehouses? Then SKUs are not SKUs. Then the brands, locations, that is done by the tree. So the decision tree will give you some type of clusters. Those cluster data is what we will use for these next level workflows. Not directly dump all that 20 million into this and then start showing nothing works then. It will not happen like that.
Okay, thank you, sir. So, sir, time for a short break and we will come back at 1 o'clock.
1:05 will come.
1:05. Okay. So participants, please, we will resume the next part at 1:05.
Okay.
Thank you.
Okay. Oh, yes. The second box, we can review the demand, even though forecast may say all that. I think our production manager or someone can edit that because some environment would have changed or something would have changed. So this box allows you to do it. I will just open. I will not be able to explain all this today. At least the deep learning, I want to spend some 10-15 minutes and then show them how to give an input to the deep learning model, because many make a mistake there. It is a little bit tricky to do that, not straightforward. That's why. Here where you put that component, all this is there. See here the number of nodes that is equivalent to that one. What that box I showed. This is the second box. Now the third box, this is where we do the what we call the prediction part is here. Future demand. So he has used a simple regression model to do the simple demand here. There is something called a regression learner and then a regression predictor. Now this can be replaced by your boosted learning here. For a demo, we have taken only the regression, or this can be your deep learning model also. Here all this will remain the same. We are not changing. See See the time you save when you use these workflows. We are not touching here only. By editing few of these nodes, you can build a separate workflow altogether without spending right from the scratch. I don't know if someone wants to write all this from Python. I am not very sure how much time it takes, because normally I am a little bit scared to put my hand into any programming language, because the moment you put your hand, some library version will change, something will happen, some code will start working. Again, you will go back to pip install var is equal to 1.2. Again, you will say conda install, uninstall. This whole story comes. So somehow I will try to manage with these type of thing. There also you can create what is called an environmental variable and use that Python environmental variable to run the workflow. Otherwise, automatically sometimes it updates. When a newer version comes, your original version will get updated, and some other version, that conflict will come, and the whole workflow or the whole code may stop working there. To write this much of code, it is fairly complex. It will not happen in a day or two. Probably it may take 1 month or I don't know, more than that, to debug all that libraries. And again, to deploy into production, we get some other issues like documentation of the code. Then is it a level 3 or level 4 testing they have done? All that comes into the way when you want to deploy it in the organization. That is another trouble. The moment you write a code, why will they accept? The top management always have some apprehension about that. Something may happen here. What will we do like that? So again, they will say, where is your documentation? Who has tested? Whether it is alpha level testing, beta level, has it gone through all these processes before we move there? Then it becomes a big thing. When you use a standard workflow, you can always tell that this product has been deployed at XYZ. What all we have done is, instead of a linear regression learner, I have simply changed these node. Nothing I have touched, and these node code you have not written. It has been written by somebody else who has done all this quality control testing, alpha, beta level, all that. That way it becomes a little faster to deploy when you go for these type of workflows. Rather, not that it cannot be done. You can write the native Python code for all this. In fact, it runs a Python engine at the back end, I think. It runs. Or it is a Java code that is running at the back end. One of them it is doing. For deep learning, it is all Python. I think for this type of thing, he must have written a Java code because sometimes it is much faster, and all these libraries will not be there that much. It is a native code and you will have full control over the code. That is the advantage of Java. So that's what it is. This is what I am telling. So I will open 1 or 2 boxes and then show it to them. This is the expansion of that box. Whatever that red orange box you are seeing, this is the expansion of that. Something I will show here. There is a scatter plot here. Let me plot it. What it gives like that. That reorder level historic demand, he is showing all this in a pictorial way, what to reorder and what not to. Those 3 reds you are seeing, you will have to reorder that. You are seeing those 3 dots. Those 3 dots have to be reordered. The green fellows can wait for some more time like that. That is your original workflow. This workflow, I will mail it. So that they will be able to play around this and learn much better. I will open one deep learning and then just show it so that how it looks. We may not be able to do justice for that. Let me see if it is already there. Just let me see. No, not this one. I will close some of these workflows. Sometimes it is getting stuck here. All these we will close. And this I just showed it for their demo. We'll close this one. This is the deep learning I want to show. What it does, it tries to predict the cycle demand for the next 8 hours or something, taking your previous 10 hours demand. Here. This is cycle demand I will show the input file. This part I will explain because this is new here. There is no ARIMA and all. This is your deep learning model. Keras input layer, and there is an LSTM layer here. There is a dense layer, and this is the learning. Instead of ARIMA, this network learns. Instead of ARIMA, you saw that ARIMA box, there is no ARIMA box here. And in that warehouse management, what he is trying to tell, you can input this part of the node into that instead of that simple regression. You remember, you saw only simple regression node here. Instead of that simple regression node, you can put these boxes there. That's all. All others will flow. You don't have to touch any other thing there. This you copy and then put it there. That becomes a DL model there, deep learning model. So I will show you the input. What we are doing, this count. Count is the bicycle demand. And then T1 and T2 are the demand for the previous 2 time periods. This is the humidity, wind speed, the weather, whether it is a holiday or it's not a holiday, whether it is a weekend or it's not a weekend, because the demand for the bicycle changes with weekend and then non-weekend. This is the season, like that 3-4 months, whether it is winter season, summer month or winter month or that one. So we have not taken all the months. It is only, there are about 17,414 records in this. You see, deep learning, it requires a large number of data. That is another problem. Whereas your ARIMA, making all the previous models, what I showed, on smaller data set also they work. Whereas the same data set, if you give here, sometimes it makes a mistake. These nonlinear models are highly unstable for small data. That is the reason for this. This is the season. 1, 2, 3, 4 like that. That is the season part. If it is a weekend, we will put 1. And if it is not a weekend, we are going to put a 0 like that. Again, 1 has come. So some are weekends, some are zeros. This is the weather. Weather code. They have put the weather code into high, humid, normal, something like that. These are the 1, 2, 3, 4 codes you are seeing. Again, this wind speed is also put into some bins. Like 8 bins. No, it is normal. I think this is in knots or kilometers per hour. That is the wind speed. Humidity, 90, 93, this is again a number. So T1 and T2 are some windows of this count. This is what we are trying to predict. So count is the dependent variable. All these will become the independent variables. This T1, T2, humidity, wind speed, weather, is holiday, is a weekend or season. This will become the input. Now, how we define, I'm not able to tell the theoretical part of that. So there is something called an LSTM layer here. What it does, you keep on giving the time series, it will automatically decide how much back period it has to take to forecast for the next period. That is what it is. So here what we are doing, there are 13 variables here. There are 10. With that, we will add this date field and the time field. So it will become 13 variables. See, 10 is your original variables. Then in this box, we have added the month, week, and the hour. So your input variable to the Keras will be a 13 data. See, day of the week, that 1, 2, 3, 4, 5, 7 will come here. And then this is the day of the week, 7, 1 like that. And this is the hour, 1, 2, 3, 4 up to 24 it goes, then again it goes up to 23 like that. These 3, this meta node added. What it did, it took the time field and then broke that into fields. Day of the month, day of the week, month of the hour. That is done in this data. So if you expand, you can see what are all is inside this box. That is what it is. These 3 did that. Otherwise, this workflow becomes unwidely very large. So 13 is your input. And now what we are doing, there is something called 10 steps here. So I am trying to use previous 10 data points or previous 10 rows to forecast. That is this 10. It is something like creating a lag. It is something like sales for September is dependent on August sales, that is lag 1. July sales, that is lag 2. June sales, that he is doing. So what 10 steps means, the previous 10 steps I will use all those rows to predict the count for the next step. That is what it is. So if you come here, let us open here. So somewhere if you take the 10th row, here you count 1, 2, 3, 4. 39 plus 10 is 49, 48. So it will use these three data to predict for 49. Then again, it is something like a moving window. Then it will go from 40 to 51 to predict for 52. Then it will go from 41 to 52 to predict for 53. That is how we have built up this deep learning network. It is a one-step prediction. Any question? So this Keras documentation will give this. How do we give? I will show the input here.
So there are no questions. Yeah, okay,
so
okay.
there is a shape there. There is a shape is 10. That is, this is the time step, and this is the input vector, and they are integers. This float 32 means it is an integer number we are giving. Floating point number, 32-bit floating point number. Then there is something called a Keras dense layer. I think probably this might take more than half an hour. I will just show them and then show the prediction. Then configure. Here all this will come. What is the since it is a nonlinear type of model, we put what is called the activation function for each of these layers. Either it is a hyperbolic tangent or something called a rectified linear unit. Most of the time, these are the defaults in your Keras and TensorFlow. So first you try with this Keras. Then the output layer, there is only one layer. That is the prediction for the next. Output unit is only one. That means it will predict for the next time period. I have run this one. It takes quite an amount of time to run. I will just show the output here. There is something called the learning monitor here. You can see here the loss. The loss function is continuously decreasing here. When we started, it started with a high loss. Over a period of time, it has come to 0.007 on the training data. And on the validation data, validation is something like a test set. It has come to 0.004. 10, 100. 0.4% is the error. Whereas in your other classical model, it was quite high. That was high for this. Anyway, data set was also different. You can try the same super sales, that superstore data set using deep learning. So we have done simple model, Orima, then the deep learning. So all of the three, one of them will happen to be the best. You employ that in the production. That is what it is. Then I will show you the numeric scorer node and then run it. You will execute the node. It will give you some idea. Statistics. He has given you RMS. This is your mean absolute percentage error. Convert to you, multiply it. 1 and then 10. 10% is the error. Between the predicted count and the actual count. That we can see here. 1921 is the actual count of the bicycles for this 15677 row. 2443 the prediction. 1752 is the actual. 2203 is this. 1408 and then 2406. That is the prediction. You can play around with this deep learning. I am not able to cover much of it today. There are a lot of parameters. That is called hyperparameter tuning. Using that, we can build an optimum deep learning network. I think there we will stop because this will take, I think, another 2-hour session to completely explain this. That is why.
Sir, there are a few questions which
yes,
now.
Yes.
So shall we take them?
Yes.
Okay.
Yes.
Krishna is asking back testing in deep learning question mark. So he's asking.
Here, we have done the back testing here. 50% validation, 50% testing. And then here, what has happened? Again, we have split them into validation and then testing here. See here. It is fine tuning the model. And this part is the validation here. Here. 1737 rows we are validating, and then here in the partition what we have done in this again 1732 is what we have taken for here. In this, to fine tune the model, see here 1732, in this half of them has come here. 50% is for fine tuning here. After this it is built.
Okay, so Soumya is asking, is there any hyperparameter tuning in the KNIME model
No,
for
it is there.
improving
It is available.
accuracy?
It is available.
Okay, sir.
What it does, it will automatically select the number of units in this LSTM layer and then some L1, L2 normalization, all that I did not show it today. That it does. There is something called a parameter optimization loop you will have to put here, and you put here parameter optimization closed loop. Then those parameters will go to learning.
Okay. Krishna is asking, do we use Linux loss function or MSE?
I think here it was used is the MSC, because it becomes little easy for me to interpret the MSCs, or even you can use MAP, mean absolute percentage error. It provides 2-3 loss functions.
Okay. The next question is from Prasad. Will LSTM replace ARIMA model?
Correct. No. I will answer this question. What happens? ARIMA is a simpler level model. See what happens if you can get a good accuracy with that ARIMA, go ahead with ARIMA. It is a little easy. It is a linear model interpretation also, that ARIMA coefficients you can use and do a sensitivity. Like if some parameter is down by 10%, what will happen to the forecast? That is little tough here. You will not be able to do that type of sensitivity analysis directly here. But ARIMA is not able to capture some type of what somebody raised that issue. You know, if it is a random walk is totally different. If it is close to random walk, ARIMA will not be able to capture, and your MAP may become 18% or 20%. Whereas if you use this deep learning, only problem is deep learning is you need lot of data points, whereas your linear models does not use it. It is not that sensitive to large volume. So when once you have a large volume, definitely you can use this. And what happens is the prediction of this will be much better than your ARIMA. But if you are stuck with small data points, never try this. This will become much worse than that. At least you should have 200, 250 like that. Even here, it is not 200. See the data size they are taking. It is all 17,414. Those type of numbers is what they are speaking.
Okay, sir.
But in e-commerce sites and all, sir, product level, even if you come to brand level and all, you will have enough data points. I don't know where is the shortage. Daily sales are there nowadays, so you will have data. Even if you have 1 year of data or 2 years, at the daily level, you landed up with 700 or 600. Probably we may aggregate it to week and then try this. With some risk, you can always try this. Only thing is you put less number of units here, don't put large number. And there is a rough rule of thumb which says approximately how many numbers you will have to put here. Play around a little with this. And if ARIMA, see, always this forecasting, no single model. That is what we are telling, the model development time. So during the development time, these developers have to do this work. Then finally they will have to tell the management, they will give a presentation, tell, okay, this is all what we did, this is the accuracy, I am going to move this to production, like that.
Okay, sir, Ajit is asking, sir, can you please explain the hyperparameter using tuning using KNIME, like exhaustive?
No, I have not written in this at all. That is a separate workflow. I have not put in this.
Okay.
KNIME, there is something called what we call that hyperparameter tuning. There is a small book or something, but KNIME uses Keras, so there is nothing called KNIME hyperparameter tuning. He will use the Keras hyperparameter tuning only at the back end. So all that Keras documentation, if you read, it is applicable to KNIME, because these things KNIME has not written. See here, these are all Keras nodes. So Keras is developed by Google. So obviously Keras documentation is applicable here also. You don't need separate documentation called KNIME.
Okay. Sir, Manu is asking, 75 epochs is large. Will it lead to overfitting?
No, overfitting you can see here. But it has not overfitted because here it's not that bad. You reduce it. What you do, start with 30, 35, it's all right. After all, you are not going to give a commitment to the management that deep learning model I am going to give you tomorrow. If somebody gives a commitment like this, they are in danger. You will not be able to do. What you do, give them some 15 days or 16 days and then say I will come out with a model during that 15, and there is something called the loop start and the loop end nodes in the KNIME. There this will become a looping parameter. So epoch will become a loop. You say start with 10 and then increment in 5 units. So automatically it will execute all these nodes in increment. Then you collect. After that, within the loop, you can collect those MAP or something for each execution of the loop. Then what you do, you take the maxima of that or top 2 people out of that, minimum error out of those 2. See, you will have to put all those nodes. You see, these are demo workflows. To put it to your production, you will have to do some additional work. Who said, I never said that you directly put it in your production and then go there. No. I am not telling that. There are additional loop. There is something called the loop start node. So in the loop start node, you start with epoch is equal to 10. Then you give an increment. So it will do for 10, 15, 20, 25, whatever you put at the start, loop start and then loop end, it will automatically execute.
Okay. Sir, Jasmine is asking, how do we find the confidence interval for the predictions? Confidence interval for the predictions.
What you do, you got the prediction, you take the standard deviation of that. See, if I predict it for 57 data points or 52 data points, both during the what we call the testing stage, you have the 20% of the data kept apart for testing. Now this has given a prediction. This prediction is the mean prediction. So for this 57 data points, you compute the standard deviation. You take 2 sigma. You add 2 sigma to those predictions. That is your confidence interval for the prediction. That can be done using that maths node. We have not shown all those nodes here, but still there is a way to do it. You go to that maths node and then compute sigma for those 57 data points. It may be something like 4.2. 2 sigma will be 8. So your upper bound and lower bound for 57 will be 57 plus 8 and then 57 minus 8. That can be done with this maths node. It allows you to do all these computations.
Sure. Sir, Madan Lal now is asking how many hidden layers should we have in our deep learning models?
That is a $1 million question he is asking. There are some rule of thumb. I will give you, those books will give you approximately. It is one rough rule of thumb is 2/3 the number of inputs plus outputs. Most of the time it works. So if I have some 15 inputs and then 2 outputs, see 15 plus 2 is 17. Take roughly 80% of that. 8 or 9 it comes. Approximately around that you can play around. You can reduce it. You can make it twice. Within that you try.
And then we have the last question, sir, on the screen from Krishna. How do we combine various models for optimization and sensitivity analysis on prediction outcomes?
Wait, correct. Sensitivity analysis you can't directly do with this deep learning because it is a black box. So for deep learning to do sensitivity analysis, you have additional modules called that explainable AI. Those modules are there in KNIME. You will have to put it afterwards. With that will give you variable of importance. Which variable is more important, and if you change it by some 10% or 15%, what will happen to the outcome like that? These are called explainable AI, which I did not cover in this class, in this master class. Then you have that linear models also, like that ARIMA. So ARIMA will give you the ARIMA coefficients. So using that coefficients, you can find out if this coefficient is increased by 10% or reduced by 5%, what will happen to the outcome like that. That is how it has to be done. That is a separate, it becomes a separate master class altogether. We have not combined that here. That's why.
Sure,
That's
sir.
why.
So that brings us to the end of all the questions, sir. There are no more questions. So
it was very interactive. I liked it. As teachers, we are here to clarify all their doubts. I hope majority of the questions I could answer. You still they are unanswered. You share my email ID. We will try to answer. That is the first part. The second part, some PPTs and some textbook they were asking and all, and along with the workflows, I will send it to you. You please send it to all the participants. They can download KNIME. All of them who have that 16 GB RAM machine, they can download the latest version. Those who have 8 GB RAM machine, you go to archives in KNIME. One previous version, that is what I also have. See, if you come to help, you say about KNIME, it will give you the version number here. Mine is 4.5.1. So now it is a little bit higher. It may be some 4.5.6 or something. Those who have only 4 GB RAM, you come to that version 3. Before that, they have that 3.1.0 or 1.1. But you will not be able to do all this Keras and all the deep learning, forget it. You will be able to do the up to that ARIMA part what I showed. The trend, seasonality, additive seasonal model, multiplicative models, then that ARIMA, up to that it works. You will not be able to put all these TensorFlow, Keras and all here. These modules will not run that 4 GB. It will require 8. They are heavy code, you know what? Even though you see an icon here at the back end, that whole library is sitting here. Install NumPy, install Pandas, all that he has done on your behalf.
Sure, sir. I mean, this was really an insightful workshop. Thank you so much, for delivering this impactful workshop today. And it's always a pleasure to have you with us, sir. And I'm sure the participants have lots to take away from the demonstration of the workflows and deep learning models on the KNIME platform. So we really look forward to another workshop with you shortly.
With this deep learning only we will do. Then it will be a justification and that explainable AI. That part we have not covered here. So that will help them to move a model to production.
Yeah, sure. So, I mean,
but without this basic, they can't go there. That is the problem. Some nodes they will have to edit, some additional nodes have to be put. So without learning the basic at that level, how do you modify some component, how to change the component? You will have to delink the component from the network. So those things have to be done because all the components are stored on the KNIME server. So if you do any modification, it gets modified there. So that they don't want it. So you will have to delink and then put it in your local machine here and then do the addition. That's why. Those part we have not covered. And they can all become that community of KNIME. They can register. So you will get blocks are there in KNIME. And there are a lot of tutorials on their KNIME site. There are a lot of PPTs and other things also there. That is what it is. It's a very powerful product starting from basic mean standard deviation to explainable AI, XAI. Only thing is they need that 16 GB RAM to put all this.
Yeah, sure. So, I mean, I would like to thank our participants also today for, for your, making it very engaging and posting your questions. And Dr. Chandrasekhar have been very patient and diligently answering to all the live questions. So thank you, sir, once again. Please keep yourself, follow our social media handles to keep yourself updated on our upcoming programs. And we value your feedback. So please do provide your, inputs on today's workshop in the survey link provided. Thank you everyone and wishing you a great day.
And also Supriya for nicely moderating the session.
Thank you. My pleasure, sir. Thank you. Okay, bye-bye everyone.
Okay, good afternoon to everyone. Okay.
Everyone, bye-bye.
Okay. Bye.